Yeah,
All right,
started.
we're recording. Okay, so let me open up the syllabus first, which actually isn't overly interesting, but it tells you what the grade breakdown is. All right, so this class is going to be weird. We're going to have, so historically, the research class was 16 weeks, all research. And we're going to be kind of doing that half the time, and the other half the time, we're going to be doing embedded systems with Arduinos. That being said, rather than having 8 weeks of one thing, then 8 weeks of another thing, we're going to intermingle the two. So we'll be doing some embedded system stuff, and each research assignment, then you'll have 2 weeks to work on that. So a little bit more time to read and write while you're doing, let's call it the fun Arduino projects. And today we'll end up breaking out the Arduinos for a good portion of class probably, and starting to go through getting the Ide installed and maybe doing the first couple of projects so everybody can make sure their thing works and if there's any sort of issues. So if you do have a laptop with you, it'll be helpful for you to have that out so you can download the software and stuff like that as we go. But we'll burn that bridge when we get to it. As usual, I have Bible homework in my classes. Notice that it is worth less than it used to be worth now. So it's worth 10% of your grade rather than the same as homework. Too many people were just writing Bible homework to reasonable grades. So this semester, we're going through the book of Luke. If I go back in here, all the Bible homework is already up. There's 12 assignments, roughly due once a week. You can do them all up front if you want to and just get them submitted. I don't necessarily care. One thing I do want to promote, though, is the idea of getting into the Bible every single week, maybe reading a couple of chapters and reflecting on it in your life. This is 10% effectively I'm giving you to force you to read the Bible. 3 points, do it. So for each of these, you'll read. So for this coming Sunday, you're going to read Luke chapter 1 and 2. You'll just read those chapters in the Bible and then write a couple.
On Sunday?
For
Coming
Sunday,
Sunday?
yeah, each one, they already have a due date.
Okay.
The due date's in there for each one.
Okay.
But yeah, they're due midnight each Sunday.
Okay.
And a good way to kind of see when stuff is due is if you go to course tools and scroll down to course calendar. You can see, for next week, the first embedded systems assignment is due. Bible homework is due on Sunday. Following week, you'll have another embedded system.
Yeah.
And then so on and
Another way we can click that link, then
I
it
think
will
you can click this and it takes you to the assignment maybe. Mine says edit the assignment because I wrote it, so I don't know if you can actually click it, but whatever. This shows you, this is a good way of seeing what the class is at a glance. But you'll see each week there is a Bible homework assignment that is due. So all these guys. Notice on the 23rd is when we have our first Tech Talk due, the assignment. And if we go back into content here, we have this semester 2 Tech Talks. Okay. So last semester we had 6 or 7 of them. We have less this semester. So on February 19th will be the first Tech Talk from 6 to 8 p.m. That's going to be over in the business building. So mark this on your calendar. This event is going to have, his name is Eric, A-R-I-K. He is the CEO of Aurora WDC, which is a data science. So actually, Priscilla will probably like this. It's a data science, machine learning, business analytics company based in Madison with offices around the United States, and they're about to open an office in Milwaukee. A couple of our undergrads are interning there. So that should be a pretty good speaker. So after you go to the Tech Talk, and Josh, for you, we do stream it over to Ann Arbor, so there'll be a link to listen and watch the live stream.
Okay.
You'll be able to see it, unless you want to drive all the way over here. We'd love to have you.
Yes, but
no.
yeah.
Okay, I get it. Yeah. All right. Yes, but no. Okay, so that is on the 19th. So mark your calendar for that. I don't know what day of the week that is. I think it's a Wednesday, isn't it? Yeah. So I've already talked to Dr. Locklear. So those of you who are in his class, he will, I don't know if he's canceling class or bringing you there for the time period, but you won't have a problem. It's going to be compatible with this class. The other one is on 4/7, which I'm guessing is also a Wednesday, Tuesday. Okay, well, whatever, deal with it. So it's 4/7. Oh, I'm guessing, is that right before? That's not right before spring break. Oh, whatever. Oh, that's it. It was earlier in the week because we're getting too close to Easter break. This is a lady, am I going to mess up her name? Trisha Kane is her name. She is a CFO, or CTO, I'm sorry, CTO of a company, and she actually manages software development teams globally. So she works here, and she manages the software engineering process of multiple software development teams that are located around the globe. So pretty fascinating lady. She was actually the canceled Tech Talk from last semester. The one that was too close to Thanksgiving, and the time that was the one we didn't do last semester. So she has confirmed, she picked this day. So I think we should be good for that one. Last semester, I think it was, she said, oh, anytime should work, and then didn't realize that, oh, that's the week of Thanksgiving and we're not going to be here. So anyways, that's the scoop. So mark your calendar for both of those dates. Those are required. So if you show up to those and listen to the talk, for those of you who haven't done these before, we bring in these guest speakers, and the speaker kind of shares with you what they do. But also I encourage them to kind of talk to the audience like they're talking to like their 20-year-old self. What advice would they give to their 20-year-old self? Okay. And the format they pick just depends. Some speakers use a normal PowerPoint presentation, whatever. Some are very informal and just have a kind of a round table talk. So I'm not sure which format they're going to use. My guess is for Eric from Aurora WBC, that's going to be pretty informal. He's a pretty interesting guy, but I can see him being maybe similar to Will Tesh from last semester in terms of presentation, something like that. Although I think he's even more charismatic. Eric's an interesting guy, in a good way. I think Trisha Keynes will probably be maybe a little bit more traditional, but not boring traditional. She's pretty dynamic. So I think both of these should be good talks. And I feel like 2 is a good number. We're good with that? All right. So those are required. If you cannot make the tech talk, you have to go research the company, write a 4-page paper, and answer these 5 questions in it. Don't do that. Show up to the tech talk or listen to it and write your, few paragraph summary of the deal. Questions about that? All right, so the combination of the Bible homework and the tech talks, all those together are worth 10% of your grade. All right, and like I don't remember if I even finished saying it, but for the Bible homework, for those of you who have not had my classes before, each week you'll read, so for instance, for this Sunday, you'll go into the New Testament of the Bible, read the 1st and 2nd chapter of Luke, and then write a few paragraphs reflecting on how it relates to your life. Whatever that means. I even give you a little spiel here that says something along the lines of, sometimes things are difficult to relate to your life. Write something. Give me some evidence that you read this thing. Give me some funny thing that it reminded you of, whatever it is. This is my way of forcing you to read the Bible. And I encourage you, even if you are, want to manage your time, and, if you're working professionals and you have time a couple of, early on, let's say, and you want to just knock these out, that's great. I still encourage you to set aside some time each week to read the Bible, do something related to the Bible. I think it's a good practice to have. But you could always turn them all in early. All the assignments for the entire class are up right now. All right, so if you want to get ahead, and you will be able to get ahead with the embedded system stuff that we're going to start talking about today, all the projects are up there, and they're effectively, let's call them tutorials, but you have to do it along with it. So that It's not always, and there's code you write and stuff like that, but it is mostly monkey see, monkey do. So the idea is that if you put in the time, you could do it. So if you just wanted to have a embedded systems weekend, you can probably knock out a good number of the projects or something like that. I wanted to make sure we got through quite a bit of stuff this semester, but I also know that several of you are very busy and maybe have busier times and not so busy times. So wanted to get you all the stuff so you can decide how to manage your time. Okay, so all that's out there, and you can choose how much you want to destroy yourself to give yourself more flexibility later. All right, questions on Bible homework and Tech Talks? We're all cool with that? It's on the left-hand side, and I assume it's on your view too. Okay, so for you, you go to Tools here?
Yeah, and then it's calendar.
Do I have that here?
You should, yeah. It's down on
Yeah, so you could at a glance see what's due when and that kind of stuff. All right, so next thing I'm going to talk about, we'll finish up talking about the embedded system stuff, since that's what we're going to spend the second half of tonight messing with, and that should be a much more fun, relaxed, whatever thing. So let's talk about maybe the less fun part of the course first. Not that it's not good, it's just less entertaining. It's important, but all right, so in this course, and up here I have this overview of what's an annotated bibliography. We'll go into that here in a few minutes, but there's going to be a total of 6 research assignments. All right, and what each assignment is going to be like is you will go and find 5 research papers or publications, something that is not Wikipedia, right? So 6 papers of substance related to a specific topic. So our first topic, so this thing says read 5 research papers, articles / other reasonable sources of info on the topic of cybersecurity. Okay, so you're going to say cybersecurity is what I'm interested in learning about. You're going to go and find 5 papers out there that are dealing with cybersecurity. I would encourage you to maybe start off by doing like a search on like modern trends in cybersecurity and get some buzzword topics, and then use those to go and look at current research in cybersecurity, or at least relatively recent stuff in cybersecurity. That doesn't mean you can't say, hey, I'm interested in cryptography, and you want to go back and look at some paper from the 1980s on triple DES encryption or something like that. Perfectly fair game. We have kind of 2 goals with the research stuff. So the one thing I'll point out is we have, every time a research paper or every time a research homework is due, everybody in class will also be giving a presentation in class. Now, it's easy as an audience member to sit there and fall asleep during other people's presentations, okay? What's important in a class like this, I mean, it's more of a master's degree thing anyways, but also just as a collaborative thing, even though we're all going to be looking at cybersecurity, for example, most of you are going to pick different papers or different topics or potentially unrelated topics. So as an audience member, when the person's up here giving their presentation, what they're presenting is on the 5 papers they talked about, kind of summarizing those 5 papers. So you're learning about what they just spent the last couple of weeks learning about, because you spent the last couple of weeks learning about something else. So this is a knowledge sharing type thing, almost like we're at some sort of conference or a symposium giving our little talk. Make some sense? So try to stay awake during other people's presentations and maybe take some notes, things like that. We'll talk about the midterm and the final here in a few minutes. High level things from presentations would be fair game for the midterm or final. I'll make that make more sense as we get closer to those exams, but I won't ask you some sort of detailed question about a very specific person's paper number 3 and something they talked about that was, very, very detailed. Yeah.
Where are we supposed to find these?
The internet, the library. Yeah, no, well, you don't even go to real libraries. You just do online libraries. Yeah. So if you just do a search for cybersecurity, pick a topic in cybersecurity, maybe cryptography research papers or cryptography academic conferences. You'll find a proceedings from these conferences that will have a bunch of papers attached to them.
Excuse me, Dr. Littman.
Yeah.
We have to, if we be interested in some other topic, and there are different topics are there in cyber security, you know.
Mhm.
So if whatever we feel that we can select the topic, the area, and then we can do research. That's what you want to
Correct.
say.
You get to pick your 5 papers.
Yeah. Another thing is that every assignment and research after that we have to present in a coming class.
Yep. So I'm gonna talk about kind of the flow of this.
Okay, thank you.
Yeah. So question was, where do you find the papers? Start with Google, but ultimately you're going to end up with getting papers from the proceedings of some conference. You know, such and such. You know, symposium, the 114th symposium of such and such cybersecurity or whatever, and there'll be a whole bunch of research papers that read like stereo instructions. So one of the things that you're going to get used to doing in here is reading. I mean, this is something academics tend to do, is when we write stuff out, we tend to write it in ways that make us sound more impressive than our words. So your job ultimately is we're going to be writing this thing called an annotated bibliography, which is effectively a summary. So you're going to read this, let's call it relatively hard to read research paper, and then summarize it into a couple of paragraphs, you know, translated for humans to be able to digest type thing. Because what you're actually doing is you're reading this person's research, which I'm sure has good stuff in there, but you're trying to get past all of their fluff because they used a whole bunch of big words and, you know, things that made them sound smart or something like that. Go ahead.
So is there like a age limit on how old the paper can be?
I don't care as long as it's appropriate. Yeah. So I mean, you know, like Josh here was asking about, you know, like for instance, if I just go through the use case, we'll think about what our first assignment's going to look like. It's due on week 3. So you have 2 weeks from now to read 5 papers, write an annotated bibliography, which we'll talk about, and generate a 20-minute presentation.
Is there also a limit on how long these papers should be?
Long enough?
Okay.
Yeah, I'm not going to sit there and like decide whether this paper is, you know, great, good, not so great, whatever. It's, you know, you're going to pick a topic in cybersecurity that you're interested in and find a paper that you can look at that and at least with a little bit of squinting say, this is an appropriate researchy type paper, whether it's something that was in a conference or maybe it's a couple of chapters out of a book. That would be reasonable. Maybe it is a website that you found that seems legitimate, not, you know, something that you know, somebody's blog or something. But, you know, I'm not overly concerned about the source of the knowledge as long as it feels legitimate.
Okay.
Something along those lines.
And then I had so there's 2 different like drops for the first assignment. So for the first one, you basically want our summary, and then
Yeah, this is the first one, research homework 1. This is where you'll turn in your annotated bibliography, which is the summary of each of your 5 papers. And we'll click on this link here in a minute that gives you some examples of annotated bibliographies. All right, so that's what you'll submit here. And then I tell you to prepare a 20-minute presentation here. You'll be giving that in class, your presentation. But before class starts, I want you to submit your slides in the second Dropbox so I have something to grade. I'm not going to grade your slides so much as I'm going to grade your presentation in that Dropbox where I have your slides.
Do you want us to submit the research papers or articles as well in the first one, or just wanting this?
If I can't easily find them on the web, let's say maybe. Most of them you're probably going to be able to give me a URL and you'll put that in your summary. So make sure I can get to the papers one way or another, whether that's following a link or you submit it. I guess my preference would be a link, but one way or another.
Excuse me, I just have a question, Dr. Littman. And after submitting the research paper, in research paper, do we have to have like a bibliography in note for note some kind of stuff that people do like that? Do we have to mention from where we have.
You're not actually writing a research paper.
Yeah. Okay.
What you're writing here is an annotated bibliography. Let's go look at that real quick.
Okay.
I'm going to click on this link here, which just takes you to Cornell University. They had a good summary of this. So this talks about what is an annotated bibliography. Effectively, it's I already mentioned it, you read something that's kind of difficult to read and you summarize it in something that other people can read. Realistically, an annotated bibliography is actually for yourself. So when you do research, like when I wrote my dissertation, I had to go and read all these papers, things I wasn't interested in, things I was interested in, whatever. And you effectively go and you summarize each one so that later on, when you go back and have to figure out which ones are pertinent to what you're ultimately going to do and which ones are not, you don't have to go and reread the papers. You can reread your paragraph, because in that paragraph is where you summarized in your words, which probably you're going to be able to understand, right? You summarized in your words what you got out of that paper, what that paper meant. So when I was going through the paper and I had this idea of what my research topic was, I was already working with an advisor and things like that, I was probably being very focused in my annotated bibliography, pulling out the parts that were only pertinent to what I was working on. Well, in here, we're not necessarily focused on an individual thing, but let's say you read you're reading through one of these papers and the papers talk about, let's say it's to Alexis's point, maybe it's this really big paper and you're really only interested in one encryption algorithm, RSA or something like that. And the paper talks about 6 different encryption algorithms. You might pull out the pieces specifically about RSA and choose to focus on that aspect of that paper, if that would make sense. All right, because ultimately in class, if you're thinking about, I'm going to be giving a 20-minute presentation to my classmates about these 5 papers, you're going to only be able to spend a few minutes on each of your papers, right? And, if you have, your paper talks about 14 different encryption algorithms, you probably don't have time to talk about 14 different encryption algorithms, but maybe you get up and talk about RSA and why it's considered good encryption and how prime numbers play into that and that kind of stuff. So you're going to create a summary for a paper based on what you personally got out of it, whether it's what the paper as a whole said to you or what parts of the paper you were interested in the material for. Make some sense? But at the end of the day, you're going to have an annotated bibliography with 5 sections. So here's an example. So this would be paper number 1. This would be paper number 2, so on and so forth. All right, so here's the paper I read, give me a link, whatever, and then here's my summary. Got it? Go ahead, Ani.
I was confused by when you said paper. I thought that you're creating one of those annotated bibliographies and that you have them, but we want on.
Yeah, you're gonna have one document you'll submit to me that will have 5 sections like that on it. And let me guess, your question is how long does it have to be? Oh, good. Oh, well, no, she asked how long the paper has to be. Ani wants to know how long does your summary have to be? Do you? All right, Ani wants you to ask that question first. I don't care. Their summary has to be long enough. If I were looking at this as a summary, at a glance, I might say that seems a bit short, but if it says everything it needs to say, that's fine. So the paper is going to dictate how much you have to summarize. Ultimately, between this and what you give in your presentation, that's what your grade is going to be kind of made up of. But I'm grading the annotated bibliography on its own. You won't, if you have a junky presentation, that's not going to hurt your annotated bibliography grade. Good. Oh, I already said multiple times. It's 20 minutes. 20 minutes.
Okay, so 20 minutes times 14.
Yeah. Well, that's usually the case.
Really?
Nobody. Well, I want you to all make it 20 minutes.
Okay, but we wouldn't get I want to know what your expectations of the presentation.
So do we have to submit together? For example, if I have slides for my presentation, do I have to submit slides and plus presentation research paper together?
Nope.
Do I have to
drop boxes?
Okay.
So week 3, you'll turn something in for research homework 1. And for week 3, you'll turn something in from presentation slides 1. So slides 1 will be your slides that you're going to present with.
Okay.
And research homework 1 will be
Okay.
your annotated bibliography.
Oh, I got it. Yeah. Thank you. I saw.
Yeah, 2 separate things. Yeah. So that's the punchline. So your point is are we going to be here past 10 o'clock? I think it's probably unlikely that everybody goes 20 minutes. But if we're past 10 o'clock, that's the way it'll be. If you have to leave, you can leave. You know, you're all adults. You can. I'm not going to take off points if you have to leave. You know, I encourage you to stay for as long as you can. You know, the first person should get just as much time as the last person, but history kind of says people don't go 20 minutes. I'm not going to, let's say you go 17 minutes, you're probably not going to lose points. If you go 5 minutes, you probably will lose points.
So if the content is there and it's only 12 minutes.
Let's say yes, that's probably fine, but we're probably getting into a gray area there. 12 minutes seems maybe short if you're giving me information about 5 papers, but if you can give me good content in 12 minutes, that's fine. Content heavy, I should feel like I read your 5 papers and got that. You're almost like, you know, doing your annotated bibliography as a play. I can sit there and read it, but now I want you to kind of deliver it to me and fill in the gaps, because your annotated bibliography is just words written. Now you're probably going to talk about things like how does it, you know, connect to the larger field of cryptography or something like that. So yeah, I mean, if it's 12 minutes and it's good, that's fine. So I'm not grading on time. It has to be amazing.
Some kind of presentation summary.
Yeah, let's call it, if we want to summarize it, just so let's say it is a verbal version of your annotated bibliography. Doesn't necessarily have to be more detailed, but I probably expect you to somehow connect your 5 papers back to the topic of the week. So for week 3, it'll be cryptography. You know, because some papers might seem like they have nothing to do with that core topic. So, and sometimes you might pick something that's like, well, this is really loosely connected to cryptography. So I would probably expect you to make a connection to what tiny little hook in cryptography is this related to, and why did it pique your interest? Something like that. Yeah. Even if you run in the presentation? Or plug our computers into the system? I'm fine either way. So if you want to run with your own computer, you can. If you, we have HDMI up here, and we can get any dongles you might need. So it's up to you. If somebody wants to email the presentations and drive them all off my machine, that's fine too. Yeah, that's true. But whatever you want, if you're more comfortable with your machine, or you have some, I don't know, animation-y things or something you've done for your presentation, you're concerned it's not going to show up right, mine, it's up to you. Doc points for researching more. It's like if you give me 7. Oh, that's fine. Yeah, I mean, don't give me like 30. I'm grading these in the pool, and I don't want to fall asleep in the pool while I'm reading annotated bibliographies. Because you can just imagine how exhilarating reading annotated bibliographies in the pool is going to be. Oh, for those new people, I do all my grading in the swimming pool or the hot tub. Depends on where I am. I start off in the swimming pool, and I do my cool down in the hot tub. That's.
I have most important question from my side. Since I am taking class from Zoom, if I have to show my slide and explain one by one, so how do I do? Do I have to?
You'll share your screen, and I'll put you on full screen here, and everybody will see what your screen is.
Okay.
We'll hear your voice, and we'll see your screen, so it won't be any different than if you were sitting here, except we won't necessarily get to see you fidget. You know, nervously, because you'll be, well, actually, we still get the little box. We'll still get to see them. It'd be perfect.
Okay.
What?
Okay, so or maybe it's start. Says life happens. So if for some reason we can't make a presentation,
Is there a plan B for not making a presentation night?
or like something that we record ourselves.
I would say we can do that. I don't, so, you know, the question is if something happens, you just can't be here for a presentation night, you can record your presentation, upload it to YouTube.
Oh.
Submit, that way I can watch it.
The world.
Well, if you want to make it a private link and just share it with the class, that's fine too. Put a password protected. I don't know, you don't have to share it with the world if you don't want, but put it on YouTube so it's easy to see, but post a link to it with the password on Slack. So your, the expectation would be all your classmates would then watch it on their own time. Like that's going to happen. But I'm officially saying that I expect everybody to watch everybody's presentation. And I might also say that there's a better chance that somebody's YouTube presentation might have a something related to that on one of the exams, just to force people to do it.
You don't use that? But then you can watch it on your own time. So that might be better. Anyway.
Maybe you can get a subscription. If you submit every week, you can maybe some of the subscribe your channel.
Oh, okay. Of course you.
Because I don't anticipate people would actually watch it.
Right.
So I certainly want it to be an exception, not the rule, for presentations.
Well,
But
there should be like a small paragraph that you should be able to write after everybody's presentations. So if you told them this class,
You just want to make sure you need to read it.
like, oh yeah.
yeah, so well, you could choose. But if some, I mean, so I'll do that. Any presentation we present on my laptop, I'll record. Alternatively, if you want to present on your own and do a screen capture and then upload to YouTube, that's fine too. Any way you cut it, we'll get it on YouTube one way or another, unless somebody wants to use their own laptop and is just adamant about not recording. It's yeah, it's fine.
Okay.
So
Do you mind to let us know the midterm and final test exams, how it's going to happen? Just I'm wondering if you can.
I haven't necessarily thought through them yet, but
Okay.
there's a 100% chance they'll be online. So they
Okay.
won't be something you take during class.
Okay. Thank you.
And because this class is so writing and presentation focused, I don't imagine the exams being
Okay. Main presentation and
overly crazy. I don't know.
Oh.
Yeah. I don't know. I don't know what they're going to look like yet. Let's just assume they're impossible. And you
Okay.
can just write off 30% of your grade day one. And then hopefully you can get some of those points back eventually.
Okay.
All right. So that's fair.
Right.
If it's a standard exam, yes. Maybe.
Oh yeah, because it's different than class.
Yeah. The issue is I'm guessing the exams are going to be likely embedded systems heavy, not research paper heavy. So I'm saying I reserve the right to throw something about research presentations in there to keep you on your toes and make people pay attention to presentations. But if I were guessing, if there's 10 questions, 8 out of the 10 questions are going to be related to the Arduino stuff that we're going to be messing with. And since a lot of the stuff we're going to be doing with Arduinos, and we'll start tonight, are effectively tutorials. You're going to be teaching yourself about embedded systems and things like that by just following a book and saying, well, plug this into here and plug this into here and write some code, see what happens. The idea is in the end, you're actually learning about the different parts that are in this kit and things like that. So now I would ask you on the exams about the stuff that you were to have learned through those projects. Go ahead.
Do you want MLA or API?
I don't care.
Big Latin.
if you think you, well, okay, I'll say this blanketly, but I'm mostly talking to folks whose English is not their first language. The university does have a writing center, so I would encourage you to take your annotated bibliography as well as your slides, go to the writing center, or have a friend from class where English is their first language, take a look at it and make sure it doesn't read like broken English. I'm not expecting perfect writing from computer science majors, but it should be reasonable writing. And I don't care where you end up in industry, even if you're a programmer sitting in the, working in sweatpants, sitting in the back corner somewhere, you're still going to have to do email communication. And you might actually have to talk to people every now and then in person. But at the very least, you should be able to communicate with people in written format. So if I start reading your annotated bibliography and it just reads like broken English, you're probably sitting out at 80% as a starting point. Remember, I'm in the pool and I don't have a lot of patience for like crap. So yeah, so proofread your stuff, make sure it reads reasonably well. I'm not going to take off 5% because you misspelled one word or something like that. But as an overall document, as I read through it, I expect it to seem reasonable, that you put some time into it and you turned in something that looks like it had effort. Cool? All right, other questions? All right, so the cadence for these, you said it was under tools for the calendar? Yeah, we're gonna just look at the calendar for the research stuff first. So we see here that on February 13th, day before Valentine's Day, February 13th will be when your first research paper is due on cybersecurity, and your slides will be submitted. All that needs to be submitted before 6 p.m., before class starts. If your slides are submitted late, I don't know, I'll give you 50% max. Because what does that tell me? That tells me you sat here during the presentations finishing writing your presentation. Got it? All right, so turn your stuff in before class starts. So the 13th is when your first research stuff is. Then you have 2 weeks to do the next one, so 27th. Notice I have embedded systems homework in between those. Okay, so I'm basically giving you 2-week swaths to read your 5 papers, write an annotated bibliography, and make a presentation. You can decide where you want to fit that into those 2 weeks. Typical students are going to do it on Wednesday night, but hopefully most of you do it a little bit at a time. Maybe you read a paper, write a summary. A day later, you read another paper and you write a summary, and then you're not really stressing, but that won't be how it goes down, I promise. All right, so second one is the 27th. What's up? No, they all are categorized as research. So you have a total of 12? Yes. They are under the same category of research homework. It is, because it's a homework assignment. Yeah. So anything that you submit that's not Bible homework or an exam is part of the 60%. But yeah, those are all normal assignments that you're going to spend legitimate time on. Yeah. So the third research is the March 12th. Somewhere in here, so I'm 9th. This is the week of spring break, and officially. So I don't know what Dr. Locklear is doing, but graduate school typically does not get the spring break. I won't be here, so
that means
I'm gonna be in the ocean somewhere. So you guys can meet if you want. Easter, I don't know. Oh, that's what you're asking? I don't know. Let's see. I think maybe.
It's
April.
Classes end at 4 o'clock on Wednesday for undergrad. For grad, doesn't it? Because Good Friday's the first.
Which day are we talking about here?
So Good Friday's the 10th.
So this guy here?
Wait, no, it's nine. That's nine. Ooh. It's a presentation day.
That's a presentation day.
Ooh. Oh. Oh no. Bummer. Everybody has to record themselves.
Well, that's the way it'll be. That'll be interesting. Just a whole bunch of YouTube videos, make those public.
But I mean, who would watch? Like, if we all upload, are we all gonna spend our Easter break because it's presentation?
You don't have to spend your Easter break doing. You got 2 weeks before the next research thing to watch it.
But then we have to.
Here, what can we do? Maybe. Yeah, but see, then the problem is then we have back-to-back research stuff.
Yeah, let us know.
Yeah.
Get back
Well,
to us.
I'll get your opinion here, and then I'll think about it. So one thing we can do is we can make the embedded systems homework due on the 9th,
There you go.
which would just be something you submit, and then we'll have the research 4 on the 16th, but then you also have research 5 on the 23rd. So you can, I mean, you technically still have the same amount of time to do all those. You're just not actually presenting on the 9th. So the idea would be that you have actually done all the work as if you had to present on the 9th, but you don't actually present till the 16th. So you could decide to be good students and do the homework and do the work, you know, and prepare your presentation as if you were going to do it on the 9th. So you don't have to do it leading up to the 16th. So that next week, leading into the 23rd, you've already worked on the next one. I think it makes sense too, but the problem is that the procrastinators are going to say, well, it's not due till the 16th, so I'm starting it here. But those are the same people that wouldn't start this one until here. No, because you'll still, this assignment here will just go the week before. I'll make it due earlier. Or heck, I can actually do that. I can make that still stay due here and you give her presentations here. We can do that. I'm okay with that.
And quote unquote, we would get our paper done by the 9th and just not present.
Well, could you still make it do the 9th and then just do the presentation on the 16th?
Well, I can, but do you want me to make it due the 9th? Or do you want me to allow for procrastination?
I'd never know about procrastination. That's just me.
Well, the presentation will be on the 16th. So I can make your annotated bibliography due on the 9th. And then you just have to have your slides. Huh? Well, because if I make it due here, then if I don't grade it till later on and you don't turn it into the 15th, it'll show up as late and that'll tick me off.
That's a you problem.
So, and then it won't get as good of a grade. It'll probably get a very bad grade then, because then it'll be like, oh, you turned this in late. You turned it in a week late. So I'm fine saying, hey, look, if you want to be a good student, turn it in early. But if you want to procrastinate, you can turn it all in on the 16th. That's when I'll expect it. I don't have a problem with that. But the rest, you can just decide, oh, I'm going to just pretend like it's due on the 9th. Let's just do that. So we're good with this. That's the way it is. Done. I don't know, wherever Tabby wants to go. We're going cruise in March. We're going another cruise in July. A Christmas cruise in December. I don't know where we're going to Easter. Maybe nowhere because it's too short. We should go somewhere. I could go to Florida to visit my grandma. Okay, so questions about the research stuff. So we see the cadence here every 2 weeks-ish. So you have a 2-week window to read 5 papers, write an annotated bibliography, and prepare a presentation. I strongly encourage you not to procrastinate to the very end of that 2-week period and try to scrunch it all into the night before. But do what you want. All right, but you have 2 weeks. All right, so then the other part of the course is going to be embedded systems, where we're going to be working with this tool called an Arduino, which is an embedded, a programmable embedded chip. I wouldn't call it a computer because it doesn't run an operating system-ish, but it effectively has a BIOS on it that you can load your own software on, and it'll just run your program off that hardware. And we'll talk more about that as we kind of go through here, but I'll pop that open here real quick because we're going to use that momentarily. But so for next week, we're going to go through lessons 0, 1, 2, and 3 from the project book. And then you also have the Bible homework due on Thursday. Or on Sunday, rather. We're going to actually do several of these during class tonight. And really my plan is to spend most of our embedded systems classes doing some of these things during class. So class being more informal, working on almost like a lab type class, but actually working on the stuff, doing it, you know, playing around with different things, whatever, seeing what doesn't work that was, you know, in the book, but having class being a little bit more interactive to offset the, let's call it, boring presentation classes that should be amazingly informative. Right, Josh?
Yes.
Yes, Josh agrees. All right, so that's kind of the plan. So we're going to spend a good chunk of tonight getting our setup going for the Arduino. So we're, if I open up the project book here, we're going to see we're going to go through lessons 0, 1, 2, and 3 for next week. And as we scroll through here, and this is the actual, I'm going to hand these out here probably right after we take our break. But if we go through here, this is from the actual place that made our kits. So we have this very specific kit called the Super Starter Kit for Uno R3 projects. So that means all of the things that are in here can be done with all the stuff that's in the box. No, they're yours. These are presents. So you get to keep this as a present. We'll talk a little bit, actually we'll probably talk before we take break a little bit on what these guys are for. But in any case, these are yours to keep. But if you look down here, you know, this kind of gives you an overview of all the crap that's in the box. We'll talk a little bit about that when we come back through. But you see how the lessons are broken down. We're going to be today during class installing the IDE. So there's a very specific software package that allows you to, you know, this has a bunch of parts in it, but the main part that's in here is called the Arduino Uno. It's a programmable circuit board. And that guy connects to your computer and you can run software on this. So it's a combination of software and hardware that we're going to be working with. And we use this IDE to write our software. We'll talk about that today. And then we have to have some way of uploading it to that machine. And that happens through the Arduino. Okay? And we'll talk about some use cases for this as well. This is used for a lot of interesting stuff. Sometimes you can use this to program other chips. So as an example, of those of you who've been down to the makerspace, we have those zillions of 3D printers down there. So, and we wanted to upgrade the firmware. What's firmware? What is, when I say firmware, what am I talking about? Okay, so software, it's the software that runs between the software and the hardware. So it's software that lives on the hardware. So we can we replace some hardware systems with firmware so that we can update the firmware when we can't necessarily update the hardware. That's the world we're working with here. We have physical hardware here that is already put together, you know, soldered and all this stuff. We're not changing the hardware. But we get a nice little chip on here that allows us to write stuff to it that drives that hardware. So that would be firmware that we're writing to. Now, all of those 3D printers already have a circuit board on them of one type or another. Some of them actually run off of a Uno board. but a lot of them run off of some, some similar type of circuit board. And they have software that somebody else wrote using something maybe like the Arduino Ide and loaded it on there. And we're in a situation where we need to make that software a different kind of software. But we don't want to break the printer. The printer still needs to do 3D printing stuff, right? So we might go online and we might get the new OS for the 3D printer that we're looking at. We want to put the newer OS on there because maybe it shipped with an OS from a year ago, something like that, a little bit older version. And we have to somehow get that loaded onto that board. So one of the ways that you do this is by flashing that board that's on the 3D printer using the Arduino. So you start off by loading a program on the Arduino, which teaches that board to program itself. Then you can talk right to that board and tell it to load the operating system onto it. All right, so you actually can use an Arduino to reprogram something else so that you can then talk directly to that chip. Otherwise, you'll have to have the hardware set up to write directly to that board, like they did back in the, at the factory when they made the hardware. So similar to how we're talking to the Arduino, they had their own proprietary thing, or they already had the OS on the chip and soldered it on there and said go. So lots of different things you can do with these boards, but practically speaking, if we think about what can we use Arduinos for, any sort of electronic device that we have anywhere, whether you have a doorbell or sensors where somebody comes in and the thing beeps, something like that. Those are running through some sort of, we think about that as being like logic in like a computer program, right? If somebody trips this sensor, make beeping sound. That sounds like software, right? Okay, well, somebody designed this, hardware sensor that, probably puts out like an invisible beam, and when you walk past it, you trigger it, and then it says, true, somebody has broken the beam. And it's gonna send that signal somewhere. Who gets that signal? Well, you can say, well, I want my software program to get that signal. And you say, how does it get that software signal? My software program is running on my laptop somewhere or whatever. I need to somehow have something respond to that signal. So the sensor is going to send a signal to something else. Maybe that sensor's plugged into a programmable logic board. And that programmable logic board has a piece of software running on it, very small piece of software usually, that says when this sensor fires, when the sensor says, yes, it's true, somebody triggered this, then output to this other device that maybe is a buzzer or a beeper or whatever. So you have two physical devices, right? A sensor that determines whether somebody walked past it, and then a beeper that knows how to make noise. If I give electricity to this guy, noise happens. If this guy gives electricity to the programmable logic board, then you know that somebody passed by. The logic board allows you to get the input from this guy and then deliver output to this guy and make the sound. You're writing the software in the middle. So a lot of times that software is fairly simple software in a situation like that. But we can also imagine things are significantly more complex in certain examples. But here, we'll use him as an example today. So he was in my car. I picked him up to bring him to class today, and he didn't put his seatbelt on. And in a car in the United States, what happens if you start driving and one of the front passengers doesn't have a seatbelt on?
It will
Car starts beeping at you,
yeah,
right? Okay, because it has some sensor in there that knows that if there's weight on that seat, right? Because when I'm driving alone in my car, that thing doesn't beep. I don't have to like reach over and like buckle in, nothing, right? So it has some sort of sensor that determines, is there likely a person in this seat? And if so, if that's true, if that sensor has fired, is the seatbelt on? So they have some sort of sensor to determine the seatbelt on, whether it's, whether enough of the thing is pulled out, we can actually experiment with it. So he could have pulled out the seatbelt, but not actually clicked it and see if the beeper goes off. Like, did I trick it? Or maybe it's in the clicker itself where you actually have to click in the seatbelt in order for that sensor to go off saying seatbelt is latched. That would make more sense. If he really didn't want to wear a seatbelt, he could latch it and sit on top of the seatbelt. You know, but at that point, you're just being a jerk, it seems like. But you get what I'm saying. So that would be an example of an embedded system that is solving a real life problem. Remind me that my seatbelt's not on. And that required a couple of different sensors to accomplish that, right? All right, so we're going to be experimenting in an evolving level. Okay, if we kind of look through the projects here, so this is just a software install. This is going to be kind of getting that software talking to our Raspberry Pi. So before we leave today, we want to make sure that we have the software on our machines, the software is talking to our hardware, and then the very first, let's call it legitimate program here that's effectively our Hello World Arduino program is we have a little thing in here. We have an LED light. You put it in there and it blinks on and off, right? So that's Hello World on an Arduino, let's say. All right, and then we start dealing with multicolor blinking. We have inputs, buzzers. Let's see, we'll get to some interesting stuff. Oh, servos, things that click on and off. Humidity sensor, joystick stuff, IR, infrared stuff. We're going to output to an LCD display, thermometer. A segmented display for showing multiple numbers and 4-digit 7-segment display. Oh, DC motors. So the stepper motors. So if you have done anything with 3D printers are all about stepper motors. We'll talk about stepper motors and how they work. But this thing has a little stepper motor that's in it, so you'll learn how to program it to drive a motor. And you're going to start realizing as you go through this, the thing I say over and over again as I've been showing people the 3D printers and stuff like that is, as human beings, God made us to be amazing problem solvers, but we solve all of our problems in terms of the tools we have available to us, right? So we only can solve problems based on what we know about. If you're sitting in your house and you need to fix something, all you have is duct tape and a screwdriver, you're going to solve the problem with that, even if you know that a better tool that might be at Home Depot is available. Okay? But if you don't know about 3D printing, for example, that's not going to be in your arsenal of possible solutions to solving a problem. If you don't know about simple embedded systems like this, I mean, you're probably not going to use, you know, an Arduino to do some sort of major safety thing on like an airplane or something like that, like, you know, whether or not the landing gear is up or not. Might want something a little bit more industrial for that kind of thing. You got a little loose wire, gear might be up. But once you kind of have the idea of, you know, what this world is like and what are the various sensors and outputs, inputs and outputs that you might be working with, now all of a sudden you can start thinking about, oh, well, if I want to solve this problem, I can just use an Arduino to make this little thing that will let me know whenever somebody walks past that door. Something like that, you know, if you, some stupid little thing, something you might imagine. A buddy of mine years ago had made a thing with one of the earlier Arduinos to feed his fish, and you can actually do it with a Raspberry Pi too. You can write complete software. So Raspberry Pi is actually a computer, right? So it can be 100% software and then give outputs, where this guy works with hardware sensors and hardware outputs. You can do hardware inputs and outputs with Raspberry Pi. You just have less inputs and outputs. This guy has a whole bunch of input pins and a whole bunch of output pins, so you can drive a bunch of stuff at once. And the more things you have, the more complex your, you know, like the car example we had before, requires at least 2 inputs. Is somebody sitting in seat and is seatbelt clicked? If so, don't beep. Else, if somebody's in the seat and not clicked, beep. All right, so you needed at least 2 input pins there and probably 2 output pins, because you have a sound and then you also have the little red light that blinks in front of you. You know, so a couple different things. But once you kind of have an understanding of the possibilities with this, you can start incorporating it into your problem solving. All right, so that's why I wanted to do lots of projects, since A, they're available to us here in the book, and B, because it came with this, we know we have all the tools we need. One of the frustrating things that you sometimes run into is, you know, we already had this kit and we were reprogramming the all the 3D printers, for example. And I've worked with Arduinos I haven't worked with them in a while, but I've worked with them for a while. we didn't have all the parts we needed to do what we needed to do to reprogram the 3D printers. But rather than order new parts, we just kind of MacGyvered a solution with a breadboard and had wires hanging from different things. And so in the end, it worked. And we'll learn about breadboards in here and stuff like that. So I needed a certain wire and I needed a certain other wire. We didn't have either of we had the right ends, but not the right connections in between. So we built the wire we needed to build. Felt geeky, but probably not what you want measuring your landing gear. You know, but the point is, once we get introduced to this tool, now you can start using your imagination to think about what problems might I solve with this. Make some sense? All right, so questions about the embedded systems part of this. It's effectively going to be following tutorials, putting in the time to do it, and seeing the solution to build up your knowledge base of what's possible with this kind of stuff. So we'll be doing some of that in class. So come to class, knock out your parts of your assignments, but also as we get farther down, the project get bigger and bigger and bigger, where the more we get done in class, the less you'll have to do at home.
I have a question.
Sure.
For example, if I make something, you know, like a project, you know, an embedded homework, how I have to show you? That's the problem. How I can show you?
Yeah, no, I got you.
And
so what I have you do, let's answer that part first.
Yeah.
So for each of these guys, so give me all the code on GitHub. So there's going to be two parts of all of this. So one part is you're going to have, and we'll see it today with the Arduino Ide, you're going to be writing code that looks kind of like C. It's actually its own language, but it's a C-based programming language. And so you'll submit your code to GitHub and then send me a link so I can look at your code. All right. So if you haven't used GitHub before, you can find a tutorial somewhere, I'm sure, that just, you know, do a search for GitHub tutorial and it'll show you how to use GitHub. So share your code with me on GitHub. And then I want you to give me a picture of your completed projects.
Okay.
You only have one Arduino, right? And for each of these assignments, you're creating like 3 or 4 little projects. So once you're done with one of your projects and you have it working, I want your code and I want a picture where I see all the stuff is plugged in. Then you have to unplug everything to go do your next project. Okay. Right? Now, later on, when you actually start solving real problems with these, Arduinos are pretty inexpensive. So at that point in time, you might say, oh, this isn't for class. I'm thinking down the line. You know, you want to solve some problem like the door sensor where it beeps every single time somebody walks by. You get a $5 Arduino, you get the couple of parts you need for that, you build your solution, and now you're done with it. You don't take the wires off. You leave them in there, and that's now your solution. That's the little thing you invented, and you go buy another Arduino to start. But for here, you're going to keep reusing the same Arduino. So in between each project, I need you to take a picture of your thing with the wires hanging out of it and stuff so that you have your code and your evidence that you did it, so you can yank all the stuff off and go and do the next one.
Another thing is that, for example, if I go home and you have a project, you know, so if I do in home and I can practice, you know, kind of, and do something, if I can do extra something like that, and I can show you, is it going to be, you know, you're going to add our grade? And I don't know.
I won't give you more points for doing something cool.
No, not more like points. It's just like, really for example, I have little time and then I can do it. And
I got you. So instead of having a single blinking LED, you have 5 blinking LEDs. That's fine. I'm not going to take away points if you do a little bit more of the assignment.
It means, for example, my point is that, like, for example, next week if I come, okay, and before I come, I have done some work, you know, extra work. In means I supposed to go do in 3rd week. I did in 2nd week. That's what I'm thinking. If I can show and like that.
Yeah, but submit it in the week 3.
Yeah. Okay.
Yeah, you can work ahead. If you want to work ahead, you can.
But it is difficult, I know. But sometimes it may it may happen. Yeah.
Yeah, and that's fine. So I mean, and that's kind of the reason I put you know, all of these things up here so people can work ahead if they have very busy schedules. Now, having said that, we'll just throw all the things out there. Because I want class on embedded systems days to run relatively like a lab class. If you're very comfortable with the embedded system stuff and you want to work on that stuff at home and you don't think that, you know, coming to class and working with other people is helpful to you, you're probably, I mean, you won't lose points if you don't come to embedded systems days. I'll be here. I'll share the screen here with Zoom. I expect a lot of people will be here.
No, I will be there in class.
And you're traveling a far distance here, and embedded systems days are things that you don't want to do. I'm talking just not just to you. I'm talking to the whole room. You know, then embedded systems days are going to be more lab type days. We'll be working on projects, sort of kind of as a group, let's say. So if that was something where you thought I have something better to do, that would be the days to skip, let's say, something like that. But I'll be here. We'll have class, and the hope would be, especially as these projects get larger and larger and larger, that might give you the motivation to get them done by being able to work with them kind of in a group and that kind of stuff. Make some sense? All right. Questions about embedded systems stuff? Okay, so let's take about a 10-minute break, and then we'll come back and hand out our Arduino stuff and start getting the IDE installed and making sure it connects to our machines and all that jazz. Sound good? So let's call it 7. Let's come back at 7:25 Central, so 8:25 your time, Josh.
Thank you.
Let's see if I can figure out how to pause the recording. Pause recording. All right, recording is resumed. All right, so go ahead and open up the thing, and then no, you can. No, you can hold it. Blade will do my demonstration up here. So yeah. But we have 4 more coming tomorrow, so I'll just give you a new one tomorrow. So you have, because who knows what pieces we might have lost.
I don't know if we have everything.
Yeah, but the new one will have everything. They're coming tomorrow. All right.
I don't like people see people littering.
No, what he really meant is, I don't like you Americans and how you litter. How do you litter?
No, I don't like
That would have been so much better.
Litter yourself. This needs to be recycled.
He'll take it out. It's fine.
Just give you a way. You can synchronize it.
All right.
Okay. No, I do it. I am blind for a minute.
Now, see, I don't have a good way of like of showing Josh all the people in class.
Yes, I cannot see.
Yeah, did you meet him? You were in the class last night, right?
Yes, I was, but I could not see his people. And my
everybody should come up here and meet. Yeah, everybody get in line. Introduce yourself to Josh.
Be nice to people from Ann Arbor. Hey, Josh, how are you? My name is Seth. So
that's nice to meet you.
Nice to meet you too, Josh. So
yeah, thank you.
Well
Yeah.
so.
Thank you.
This is hilarious. Why are we doing this?
Because he's sitting there all by himself, doesn't even get to sit in class.
Hello, my name.
Hello.
I was in your class last night, so if you have questions, you can Slack me.
Okay, thank you.
Hello, I'm Alexa.
Hello, Alexa. Okay, nice to see you.
Alexis.
Alexis.
Alexa.
Okay.
All right, thank you.
I'm Eric.
Eric. Nice to you.
Hi, I'm Ani.
Hey, Annie. Thanks.
Hi, Josh. I'm
Hey.
Khalib.
Olive. Oh, thank you.
Hi, Josh. Karan.
Hey, Karan.
Yeah, we're good. Bring me a present.
Yeah.
You brought it?
Yep.
Well, now I'm nervous. Is that,
Hi, I'm
I
Muhammad
got your
Ishtiyaq
present.
from Hyderabad.
Okay, what's your name?
Muhammad Ishtiyaq.
Okay.
No, he didn't know. He has no clue what you just said.
Okay.
You just repeat it and say, oh, okay. What-
Muhammad Ishtiyaq.
oh, Muhammad Ishtael.
Yeah.
All right, so
Yeah.
your name is Muhammad.
Muhammad is surname.
Surname. Okay, so Muhammad's your last name by our. So you're Ishtial.
Ishtiyaq.
Ishtial.
Yeah.
Ishtiyak.
Yeah.
Ishtiyak. Ishtiyak. Okay, yeah. We're gonna come up with something better. All right. So. No, we're allowed to
Hey,
do that.
Josh.
He can wear a seatbelt.
Yes.
Yeah, this is Rahman.
Hey, Rahman. Nice
Yeah.
to see you.
Rahman.
Yeah.
Like ramen noodles.
Rahman.
A.R. Rahman. You know him, right?
What?
A.R. Rahman.
Rahman.
Music director.
A musician.
Yes.
I don't listen to music.
He won the Oscar for Slumdog Millionaire.
Oh, the Slumdog Millionaire guy?
Yeah. For that. Yeah. Hello, Josh. Devi
Yeah.
Prasad.
What's your name?
Devi Prasad.
Devi Prasad. Yeah, thank you.
Thank you.
Hi, I'm the last one. My name is Camila. It's nice
Camila?
to meet you. Yes.
Thank you. See you. Thank you. Nice to meet you.
Hello, I'm Chinese and I'm Blade.
That was so powerful introduction, eh?
So that we call him Blade. We call him Blade.
Yeah.
And so his name is Yiming, Yiming, Yiming Liao.
Okay.
And we call him Blade. He was one of my students years ago, and he's doing a second master's degree now. And
Wow.
the name Blade came from, we were getting ready to go to a hackathon, a computer programming competition.
Yeah.
And we were sitting around at lunch trying to decide what our code names was going to be. We're going to be for this the hackathon. And we decided at the table, I'm telling a story. Everybody's been quiet. And we decided that everybody's code name was going to be whatever the weapon of their country was. So he said that in China, their weapon of choice is a large blade. So hence Blade. So he's gone by Blade ever since.
Okay.
So even after we went, no, the better part of the story comes up in a second. So, but there was another guy who was on the team from, he was a Palestinian guy. And he said that they use rocks. They throw rocks in Palestine. And so we called him Pebbles. Pebbles, and it stuck. So all of his classmates for like the next 2 years called him Pebbles. It was great. And actually, Blade's mom calls him Blade now.
Wow.
Yeah. Okay.
So he is famous. No.
He's been Blade for years.
I believe it's like yesterday. I'm pushing the computer to computer support, and they call me, "Are you Blade?" I say, "Yeah."
How many years ago was that? 5, 6?
I think 4 years.
4 years ago?
4 years ago, 4 years ago, being Blade.
4 years being Blade. All right. So let me flip through this a little bit so we can look at some of the intro stuff. We're going to kind of look at coding things as it comes up rather than like do some sort of stupid crash course on all this. But just real quick, if I just flip through here, we see from I've already told you that the Arduino is basically a C program. We'll look at the general program structure just real quick. But you see we have a setup and then a loop. So setup is your global stuff. What things, do you need to initialize? If you think about this from a programming perspective, what things do I put in my constructor to get the ball rolling? And then the loop is, what should my controller board do forever? That's what it does, forever. All right, so whatever we put in that loop is the logic. It's gonna read from a sensor, whatever. Okay, so that is your structure for for an Arduino program. Let me get back up. Now, as we flip through here, we see data types, we see all of our normal, we see Booleans, chars, bytes, words, long, things that we have seen in other programming languages in the past. It's, not brand new things. A 21-bit integer. I think it has something to do with the number of pins on the Arduino. Yeah. So you can do bitwise shifts. So variables, you have your arithmetic, comparison, Boolean operators. Here's your bitwise operators, and we'll talk about those. Bitwise are like ands and ors that happen at the 0 and 1 level. Like 0 and 0 is 0, 0 and 1 is 0, 1 and 0 is 0, 1 and 1 is 1. But those are happening at the individual bit level, and we'll see uses for that. A lot of times we see that with something called masking, which I think one of the projects uses masks to do some stuff. We have our if statements, normal C stuff, loops. You have your while loop, do loop, for loop, normal things. Functions in here are C-like functions. Strings are done as character arrays. So if you've ever done any C or C++ programming, well, really C programming, let's say, because C++ usually use the standard template library, which will have built-in at least C strings, if not something newer, like from string.h. But, we see that this is basically just a character array. So this is a programming language that's not going to be drastically different than what you've been exposed to before. We're not learning something. Yeah, like last semester, for those of you that had the class, we used the Scheme programming language, which was based on Lisp. It's a superset of Lisp, and it's a functional language. And I mean, it was fun, wasn't it? But it was weird, right? It's new at first, and you had to learn it. Well, this isn't going to feel as new. Just going to be the little weird syntaxy type stuff. So as we need to go to the documentation here and look stuff up, we will, but there's already a bunch of functions that are in there that's available to us. And you can, here's a program. We see lines are terminated with semicolons, so on and so forth. All right. There should be a way to just jump back to wherever you clicked from in the PDF. Is there, and I just don't know it?
If you look at the PDF, it should have a menu on top.
Oh, up.
Yeah, you can see there should have basically.
Oh, I just be able to go back to 1.
Yeah.
Huh. That'll do it actually. That's good enough. Okay, so that's your programming structure. That stuff. And then they give us a whole bunch of function libraries, character functions, math libraries, things that you might want to mess with. Here's generating random numbers. We do a lot of random number things. All right, so this book I've given you, this is from the, this is actually from Arduino. Go back into content.
I think these ones will have.
That has this book.
Yeah.
The hardware project book. So this top book here, Arduino documentation, that's what we were just flipping through. That kind of teaches you about Arduino in general, how things work. And, so you'll use that if you need to like look up a specific function, and I'll have to do the same thing because like I said, I haven't messed with this stuff in a while. I don't think a lot with the language has changed, but regardless, that's the scoop with that. The other book is where our projects are. We'll get to that in a minute. But just as a starting point for us here, you know, you could follow this tutorial in here if you want, but we're not going to mess with that. But if we go to overview of an Arduino, this is for a prototyping platform. We kind of mentioned this earlier. As you do your assignments, you do your labs, you're going to end up with, you know, kind of going through some project, having some wires sticking out and something functioning. And then you're going to say, okay, this is good. You're going to take a picture of it and submit your code, but then you're going to pull it all apart, right? So you're using it to prototype a solution to a problem. Once you have that solution done, let's say you're solving a real world problem instead of one of our lab problems, for example, you might then decide, okay, well, what I'm going to do now is I'm going to get a case and put my Arduino and everything inside this case and protect the wires and stuff. And now this is my solution. Now, if you're inventing a new project, so, you know, think about a company like Apple or something like that when they come out with the latest, greatest, you know, iPhone or some aspect of the iPhone, maybe a new camera or something like that. Before that goes to mass production, they're going to create a prototype type situation for that. Now, they probably have tools that allow them to do that at a higher level than just plugging wires in, but somewhere in the line, you're creating a prototype solution to something. So, you know, with an Arduino, you can sit there and plug wires in, take wires out, all this stuff until you get your solution working the way you want it to work. Once you have that, you decide, okay, how do I mass produce this, for example, if it's something you want to go and sell? Chances are you're not going to sit there and assemble 5,000 Arduinos with wires sticking out of it and things like that. You're going to want to come up with some sort of more permanent solution. So you'll pick a chipset that is equivalent, where you can buy the processor, buy the chip that has the inputs and outputs that you need. You'll put it into a board that gets some power, have some sort of power source, and you'll solder all the wires so it's kind of permanently put together. We'd call that somewhat of the ghetto final solution. All the way up to, you might have printable circuit boards where once you solve the problem at the high prototype level, then you decide, okay, now I want to go and print 1 million of these boards, and you have to then look at opening your own manufacturing plant or going to some company. You always see on the news with any of these big companies, like Apple uses company XYZ for all of its memory chips or something like that, right? Because that's their supplier for something. And you know, maybe they send their blueprints to that supplier who actually generates the hardware for them, or that supplier already has NAND gates, AND gates, NOR gates, XOR gates, something like that, that Apple's buying from them in bulk to solve some problem. So there's different levels of it, but if we're thinking about where does Arduino fit in the big scheme of things, it is a quick prototyping solution for creating programmable hardware solutions to problems. And it's cheap. Okay. So key features, these are able to read analog and digital input signals. So we're going to have different kinds of, we'll see at some point when we look at the boards directly, we see that we have different kinds of inputs, devices. Like I talked about an example earlier that maybe you have some sort of sensor that detects when you've broken, if it shoots like an invisible laser or something. As soon as you've broken that line, it fires back as true. This line is done. So something like that would probably be a digital input. What's the difference between digital and analog? Go ahead. Okay. I guess maybe, but I'm talking about the nature of the signals themselves. Can you give me how many of you have ever had DirecTV or Dish Network? So some sort of digital cable of some sort. Okay. Have you ever had a partial picture? Or is your picture always perfect or off? So if you're watching DirecTV, so without any of the dish type of cable things, and you sometimes you get a bad storm, right? And it might not be raining where you are, but wherever that dish is pointing, it might be raining there. And all of a sudden you get a bad signal, right? You don't start getting the fuzzy channel on TV. Your signal just goes out. You have no signal. because that's a digital input. It's either on or it's off, right? Every pixel, if we just think about it at that level, is either the pixel is on or the pixel is off. And if you have no signal, everything's off. Now we go to the old school TV with the rabbit ears. Any of you have a TV set that had the the rabbit ears? We had to adjust it to get it working. You'd have channels that looked snowy, right? Sometimes you have maybe you never quite get a perfect picture, but you have your perfect picture, but then you have all sorts of levels in between before you can't make it out, right? Maybe you ever had to watch a TV station where you only could barely tell what was going on, like watch a baseball game or something that way. That would be an analog-based signal, where it's not a 0 or a 1, it could be a 0.3, or it could be a 0.7. There's an infinite number of measurements between 0 and 1. Does that make sense? So analog allows us to take a sampling between 0 and 1, where digital is either on or off. Typically, when we hear digital, we think digital is being better, right? And I would say from a computer science perspective, having a discrete state of on or off probably is better, right? That allows us to make decisions. The sensor is either on or the sensor is off. Did it fire or did it not fire? We don't want to deal with maybe it fired. Maybe somebody walked by the door, so we'll just buzz. Probably don't want that. But let's say we're taking, I don't know, come up with a good analog example. Well, I'm thinking about for inputs. Outputs, those are easy to come up with. I'll come up with one eventually, but we get the point of the difference between those two. So think of digital inputs, digital signals, as kind of like us asking an if statement, true or false, on or off. Make sense? So our Arduino boards have input pins that allow for either one of those. So we can sense an on or off. And there's also analog. I think there's a limited number of analog pins. We'll see on the printout. I haven't looked at this board closely, but usually there might be like 2 or 3 analog inputs, and then all of the inputs operate as digital inputs. So you have a couple that are kind of like we can go either way. So here, what do they say? Outputs such as activating a motor, turning LED on and off, connect to the cloud, blah, blah, blah. All right, whatever. So we talk about this being a programmable microcontroller. So you can control your board's functions by setting it a set of instructions using this Arduino Ide. So we'll write our code here in this IDE that we're going to install here in a few minutes. And then once we have our code written on there, we send it to our Arduino. We'll plug it in through USB. We'll upload that code to our Arduino. And then our Arduino will start looping it. So now it's doing the thing. You plug your sensors into it and you see if it works, or you see if your buzzer is just buzzing constantly, right? So like when we do the LED lab here in a little bit, you're gonna, hook up into your Arduino. You'll plug one of your parts that's in this box, a little LED light, which is gonna require some power going to it. And then it's gonna require a on-off signal, a digital input. Actually, they might even have you do it with analog to give you different brightnesses for your, we'll see what they have you do. But in any case, it needs electricity, just like a light bulb, right? Plug a light bulb in and it needs electricity, and that electricity is either on or off. Okay? So think of it like that. So we'll plug this LED light that's going to be in our box somewhere there, and then we're going to write a program in that loop. And the idea is that we want the LED to flash, to blink, on and off, on and off, on and off. So we're probably going to put some sort of pause in there because, hardware runs pretty quickly. So at some point there, if you just say turn it on, then turn it off, maybe your eyes will get tired from the flicker, but you might not notice the flicker. This kind of goes back to, how many of you have heard of something with older school, well, we have it in like monitors and things like that in TVs today, something called refresh rate. When I talk about the refresh rate of a monitor, what is that?
How many pictures in a minute, in a second?
In a second. So, how many times does the screen refresh every second? What's the measurement? What's the refresh hertz? Yeah, hertz is the number of refreshes per second, right? All right, so we don't see it so much anymore, but if we roll back in time to some, like, go look at some old movie where you had the tube TVs, the tube computer screens, and you would see in the background, you would see the monitor actually cycling. You would see the refresh rate on the monitor because of the way it did its refresh. Now, if you were sitting in front of that, you didn't notice it, but your eyes did. That's why you get eye strain at the end of the day, because your eyes were actually having to adjust to that refresh rate. Now we have what's called active matrix screens, where the refresh rate happens across all the pixels instead of individual ones. And sometimes there's even interlacing where like half the pixels refresh and then the other half of the pixels refresh and things like that. But the idea is that the faster the pixels refresh, the smoother the scene looks to us, right? Well, if all we're doing is turning an LED light on and off with no break in between, there's a decent chance we won't be able to tell it's happening. But it's worst case, it'll just kind of feel unstable. It'll be like a little buzz. Is it technically going on and off, but it's mostly looks on to us. I actually think, do these Arduinos have an LED on them? No, you get a bag of LEDs, but I think a lot of the Arduinos actually have a built-in LED on the device.
I cannot see here.
Yeah, it's right next to the reset switch there.
Oh,
Yeah, look at the little red button next to the red button. I think that's a built-in LED for testing, so you don't actually have to plug stuff in. We'll see. I'm pretty sure that's what that is.
Yeah, I think that's green line.
Right. So that gives you a nice way of testing, make sure it's working and stuff like that. But you're probably not solving major issues with a single LED. But whatever. Okay. But anyways, so that's where we are marrying hardware and software together to create this idea of an embedded system. So an embedded system, if we were kind of defining that, is our software that runs inside of a domain-specific piece of hardware. It's probably the fair way of putting it. Instead of a general purpose computer, it's a special purpose computer. So our software running inside of a special purpose computer, driving the abilities of that special purpose computer. Some common examples might be like a dishwasher or a washing machine, where it has its cycles and things like that. But a dishwasher does, like 3, 4 things, 5 things. It squirts water, it puts the soapy stuff into the water and spins some stuff and puts, drains itself, fills itself, all this stuff, right? But it really only does a couple of things, and it just has to do them in a certain order and that kind of stuff. So writing the software that controls that process, all right, with the right kind of pauses in between. You think about a washing machine, it goes through the various cycles where it fills up with water, then it starts moving around and the soap comes in, and then it has to go through some rinse cycles, and then it starts spinning to get most of the water out and that kind of stuff. So those are based on some timings, right? Okay. This is something I referenced earlier. So unlike most previous programmable circuit boards, Arduino does not need an extra piece of hardware called a programmer in order to load new code onto the board. So we load code onto the Arduino using a USB cable from the Arduino IDE. Whereas earlier, I used the example of when we used the Arduino to reprogram the 3D printers. The circuit boards that were in those 3D printers, which were not Arduinos, did not have programmers installed on them. So what we actually did is we used the Arduino to load a special piece of software onto those boards called a programmer, which then allowed us now in the future to just plug a USB cable into the printers to upload the software, to update the software. So we taught them how to program themselves. The Arduino already knows how to program itself because that's the way it was built. It's built for us to conveniently interface with. That makes sense? So this little paragraph here, bullet point, whatever, is really talking about Arduinos are good for rapid prototyping. We already mentioned it's kind of a simplified version of C++. you imagine we're probably not writing, you know, crazy video game logic or, you know, heavy algorithm stuff for these circuit boards. We're really writing decision-making things. If sensor set, do this. Fire these 2 pins to make the buzzer go and make the light flash. You know, that kind of stuff. So fairly simple logic, but we're reliant on the machine doing it constantly. So it's constantly listening to that. Lastly, it has this idea of this form factor. See, we can find a lot of 3D printed cases and stuff like that for Arduinos. So some people will create projects specifically around the form factor of an Arduino board that makes it convenient for doing a lot of different projects, or at least for learning about the electronic stuff. All right, so if we flip through here, I want to go to the board type here. What is our box? Which one are we? R3, Uno R3?
Yeah.
Okay, yeah, so the here's some various board names that all fall underneath the Arduino family. And really what we're looking at here is how much power do they require to work? What's their clock speed? So this is the CPU, right? Sort of, kind of. But really this is, we can almost think of it as the refresh rate of the device. Okay? So higher the thing, the faster the computer thingy is. Okay. This is how many digital input output pins there are, 14. 6 of those are analog inputs. So I mentioned earlier that usually a subset of them are analog inputs. So 6 is actually more than I expected to be, but that's what we're dealing with. PWM, what is that? Oh, so this is for, well, is it modulating the electrical output? We'll see how they use it in the in one of the logic or one of the projects. In any case, we're connecting to it via USB. We're going to want to remember this piece right here, because this programming interface, we're going to have to set up our Arduino IDE to talk to that guy using the correct board language, right? So we're hooking into this board via USB cable, but different boards are going to speak a little bit different protocol. All right, so we're going to be using ATmega 16U2, where you see some of these other ones in here, and we're going to see how we set that in the IDE here shortly. Okay, so let's squeeze this down some. And was this the IDE or the LED, or is that 13? Oh, that's the power LED.
It's easy to see.
Right, but oh, I think it's the amber one.
This one is
Yeah, that's the power, but I think the amber light is the LED that's built in. Okay. But they're not listed on here. That is this guy, 14. Oh yeah, LED. On your board, you will find 2 labels, transmit and receive LEDs. They appear in 2 places. Whatever. All right, so this shows you all the cables and crap that it's coming with. All right, so that's roughly what we're dealing with here. I'm going to stop on this screen. This introduces Arduinos in general. This is our documentation we'll use. You'll mostly use this for the programming side of things. Okay, if I go back here though, this other thing, the Arduino homework projects book, this guy, this actually comes from the manufacturer of these boards, and it's on the little DVD that came with it, but I uploaded it here so you have it. So this guy's going to show you a packing list of all the stuff that's in there. So, you know, at some point, if you need to identify something from one of the labs, come back here and find the picture. And that's what the guy is. But we're going to start off by getting the, and we're going to power ours for most of our stuff from a 9-volt battery. instead of having to plug it into something, although you can power it off the USB on your computer as well. All right, so first thing we want to deal with is installing the IDE. So we're going to go ahead. Do I have Arduino on here? I hope not. Do I? I do.
No.
Yeah, I do. So if you go to Arduino, the website is arduino.cc. It's going to take you to this site right here. And then we're going to go to software. Now, actually, Arduino more recently created an online IDE. I haven't used, and I guess I'm not going to recommend using it. So we want to go to downloads. Okay. But we want to download the Arduino IDE. This guy right here. So download it for whatever platform you have. I'm on Mac OS X. So most of you might be on Windows. If you happen to be running Linux, you can do it on Linux. And if you feel so inclined to donate, go ahead. Otherwise, click contribute. Man, they really want, oh, I don't want to contribute. I've already contributed, we'll just say. All right, so I'm going to download that guy. Gives me a zip file. Looks like it's 189 megs for Mac. Mine says 3 minutes left. All right, so while that's cooking in the background, I'll kind of flip through this a little bit. So whatever version of Arduino is the newest, get that. So that's what we're getting. Once you have it, go ahead and double click on it, open it, hit install. I think on the Mac, I just have to drag something to the application folder. If you're on Windows, there's probably a setup to go through that. But get it installed. This is just going to be a normal plain Jane application, nothing special at this point. I'm not sure if Mac has to load a USB driver, but we'll see. But at some point, it'll ask you if you want to install the USB driver for your Arduino. That is so it knows how to talk to, because I mean, when you plug your Arduino into your laptop, it becomes an external USB device. So it's teaching it how does it talk to this external USB device. Just like if you plug a mouse in, let's figure out how to talk to that mouse. You have one of those special gaming mice that has 5,000 buttons on it. You might have to install a driver for it to understand how to talk to all 5,000 buttons instead of your standard 3-button mouse. So the Arduino can do some extra things that it needs to be able to talk to. So it'll install the USB driver for talking to the Arduino.
Doctor.
Yep, I'm listening.
I missed. I could not able to download. I will just download. I clicked. Then I don't know where.
So under software, you went to downloads.
Okay.
And then you went to download the Arduino IDE. And are you on Mac or Windows?
I'm Windows.
Windows. So you'll say Windows app, this guy.
Windows.
Oh, you could do Windows installer? Yeah. Installer, yeah, do this top one, Windows installer.
So there is software, online tools, and downloads, and then I have
Yeah, so once I hit Windows installer, so we're down here under download the Arduino IDE. Up here it says Windows installer for Windows XP.
Just to get let me see 1 minute. Yeah. Okay. Yeah. Can you show me that? Just a minute. Just please. I missed out. Okay.
Here, I just pasted it in Slack. Click that link.
Okay.
All right, once you get it downloaded, go ahead and get it installed on your machine.
Okay. Yeah, continue download. Okay, I'm going to click.
Yeah,
What
for
is
the Mac.
talking
It's
about
just,
amount, credit card? That's not
yeah,
mine. I think.
yeah. Say, make sure you click the when you click on that, you say just download. Don't click the contribute and downloads. Just say download.
Okay.
All right, and what I'm going to do is I'm actually going to
Okay.
quit this, and I'll go ahead and move it into my, so here's my downloads folder. I'm just going to drag it into my applications folder. And I'm going to overwrite the one I have in there in case this one's newer. It is newer. Mm-hmm. If you're, which steps? Yeah, just go through the installer, whatever it is. You should get to a place that looks like this. Yeah, if you have this, we're going to say you're fine. It might automatically install the driver or something like that now. Who knows? We'll find out if it's working shortly when we try to plug our goal tonight is to make sure everybody's machine can talk to their Arduinos. Okay. So everybody have it.
I don't have, but no.
Is it downloading?
No.
Tell me what it's doing on your end.
When you have given a link, I just click the link. Okay, and I got the contribution to the software, something like that, and the price says. And then
yeah, hold on. Okay, so look at my page right now. Do you see my page right now?
1 minute. Yes, I am just.
The link.
Yeah, I can see your page. Yeah.
Right. Click right here where I'm
okay.
circling.
Okay. Okay. Yes. Now it's downloading.
Okay.
Yes.
All right, so once you get that downloaded, get it installed on your end, and it should get you to a screen that looks like this.
Okay.
We already saw this earlier where we have a setup section and we have a loop section. So this is what your standard IDE thing looks like. For what? Oh, yeah, that's fine. I really want to be able to read it on Blackboard. So if it's not on GitHub, that's fine, but make sure it is, you can paste it into, yeah, or make it, you could do it as a text file. Okay with that, yeah. Yeah. Okay. Is it downloading that slow?
Yes.
Who's still waiting for theirs to finish download? Okay, well, so all of us here have it, right? And how close is yours, Josh?
Yes, it's showing that. So, who do you like to install the device software? So I said yes.
So you're basically almost there. So just finish clicking yes and next.
Yes.
And you'll get to
Within 2 minutes, yeah, I will get, I think, in 1 minute. 1 minute. Still process going on, 90% almost is done.
Now we'll have to see if this is something that is a problem with this latest version. Oh, if you did the installation package, which is what most of us did, then we don't have the stuff below. We only have it if you have the zip. So we can scroll past this. Mac.
So just I want to let you know that it's just completed and it says show details. Should I close and again start?
Yeah, you should be able to open the application now, or it'll probably open it on its own. You should be sitting at a screen that looks like this. All right, so okay. Yeah, hit close, and then you have to go and open it on your own. Does it put an icon on your desktop or just your start menu, whatever?
Yeah. Okay.
But when all is said and done, you should be looking at a screen that looks like this.
Yes, almost, yeah. Yes, got it, sir.
Okay, so now we want to get some libraries installed. So, they're kind of saying you can go mess with the code and crap like that. So libraries are collections of code that make it easy for you to connect to sensors, displays, things like that, things that we intend on plugging into our Arduinos, things that are in the box that you have. So how do we install a library? We're going to use the library manager. So this is under Sketch, Include Library, then click Manage Libraries. So Sketch, Include Library, Manage Libraries. And this is going to have, this is kind of like an app store for Arduino Ide stuff. All right. And what do they want us to install? We're looking for Audio by Arduino. And looks like we're going to install the latest version. So I'm going to do a search up here for Audio. So here's Audio by Arduino. So I just did a search for Audio here, and it shows me the different versions. So version 1.05 is the latest. Go ahead and click install. And now you've installed that library.
Audio version 1.05,
yep.
Right? That's okay.
All right, so now our IDE has the proper software libraries to tell our Arduino how to talk to, some generic form of, so this allows playing audio files from an SD card for the Arduino Duo only. With this library, you can use the Arduino output to play audio files. They have to be in WAV format though. So get yourself a big SD card or really short sounds. One of the two. All right. All right, so now if we go to our library menu, so we can go ahead and close this. If you go to your Sketch Include Library, you see here at the top now, we have Audio. And you can see some of the other things that are pre-installed, but now we have this Audio library that is available to us because we've installed that library. And as we go through and we're going to start interacting with some of these other things, we'll have to install other libraries. So that's the process of installing libraries. So sometimes we won't necessarily, the libraries the way we just did libraries there is the libraries that have been put on the, let's just, for the sake of argument, call it the Arduino App Store. All right, so these are libraries that are distributed as part of the Arduino network. They're not necessarily all made by Arduino, but it's from people who have gone through the process of getting it up on their distribution library store thingy. Sometimes you might buy a sensor or something like that. So at some point later in the semester, I have a box of weird sensors in my office, or if you really get into this and want to mess around with stuff, you can come browse what I have. You know, some of those sensors might not necessarily have libraries that are part of the store. You might have to go out to some website and grab a zip file of the library for that particular sensor that, you know, because sometimes you'll have sensors that you have 11 different sensors that are all the same, but they're made by different companies, and one company might take a little bit of a different approach to it. You have to get the proprietary library for talking to that guy, something like that. And it looks like if I go to Sketch, Include Library, I can add a zip library. So something from a zip file I might download off the internet, I can install a library that way too. Will they give us an example library they want us to download?
I think it was just kind of saying, since it was you and you prompted.
Because who has a DVD drive? How many of you in here have DVD drives in your machines? 2.5 people? No? This is a PC right here, no DVD drive.
My other Windows, but that one said 40. No, that's so stupid.
What are you talking? Why would it be necessary? For what?
It's probably lessons right now because I don't have a computer. But
Who plays DVDs? You stream. Get a DVD from Good. Really?
yeah, so we did not have a VCR. We got rid of them.
VHS or Betamax? We had a Betamax. Oh, you found a Beta or a VHS? VHS, yeah. Yeah. Okay. All right, so let's just assume all this is.
Hopefully, it's not important that that picture.
Have a what? Oh. Are we gonna have? You can find the new library available to include the menu if you want to add your own library. Open an issue of blah blah blah. We have audio.
Where did you find this manual?
On Blackboard.
Oh.
It's called the Arduino HW Projects book.
Okay.
All right, so let's, why don't we take about a 10-minute break? I'll make sure I get all the stuff figured out that we need to do to get to the next step so we can get there real quick. And then we will hopefully get our flashing LED thing going. So everybody, and well, we need to get our Arduinos attached to our computers to make sure that works. So I'm going to fast forward a little bit here. So take 10 minutes, come back at 8:36 Central, and we will get our, what? Is that bad?
No, everybody's in Central Time.
Yeah, he's not in Central Time. Ann Arbor is Eastern Time.
Is it really?
Yeah.
Yes.
Oh, so you're thinking I'm just being stupid? Well, he's sitting in his living room. Maddie's not getting home till 11. You're not getting home till 11. Well, nobody cares about you. Well, we care more about you than Blade. All right, so 10 minutes. make sure our thing is connected. Have they told us to connect it yet? 0, 1. Yeah, we just did 0 and
It's in lesson 2. It started collecting.
Yeah.
Lesson 2 blinking start.
right. So we need to get the thing connected.
I did the thing. Well, it is all.
Keep going, keep going, keep going, keep going, keep going, keep going.
Well, this is where we need to connect.
Yeah, we need to select.
Yeah. So, and we have to connect it first, right?
Yeah, if you don't connect it, you won't see that.
Yeah. Okay, so if we look at our Arduino here, we have this serial monitor up here, this little button. If you click this, it's going to try to talk to the Arduino that's presumably connected to your machine. It's not currently connected. You do have to choose the port for it.
Button.
Well, I can't see. Hold on, there we go.
Yeah.
Well, so for me, I don't have anything plugged in. So everybody should go ahead and get their Arduinos plugged into their computer with USB. And your Arduino will have a little light that comes on. Yeah. Ninja. All right, so I just plugged mine in. Now when I go to Tools, Port, we see that I have Arduino Uno is showing up. So it sees it as dev / blah, blah, blah. All right, so make sure you select that under Port. And then when you click that serial monitor, it should not scream at you. And now show you that I'm monitoring the serial port. Now the IDE is talking to the physical device.
Dr. Littman.
Yep.
Just I want to do tools and the board Arduino.
Did you plug it in already? So you plugged it in, you went to Tools, then you went to Port. You got to plug your Arduino into your computer via USB first.
Okay.
You should see lights come on the Arduino. Oh, when you click this?
Yeah, so I clicked my, it was like the COM3 or whatever, and I had the Arduino, but it still says board at mall is not available.
Even if you click this again? So you're not getting that.
That's open, so it still says board at mall, so I don't know if like maybe the message is not.
Oh, like maybe the message didn't disappear yet? It didn't clear? Yeah. I see what you're saying. Yeah, it scrolls up.
That is not related to this one. It's related to
Yep. Yeah. Yeah, I mean, you'll be able to do all sorts of crazy stuff like that. Then you just go on like Amazon and shop for sensors, and sensors and stuff are super cheap. And now you're like, oh, I'm going to plug that into this. You can do things like at work with an Arduino plugged into your USB or something like that, and you know, have like mess with K. See? Yeah, you're absolutely, that's true. Okay, so you should have the serial monitor now proving that your Arduino is connected to your machine. You've selected the right USB port, so now these guys are talking to each other. Everybody's good. Okay. Mine auto-selected 9600 baud. So this is the speed at which it's going to communicate over that serial channel. Why do you think that speed is important? So notice here we have 9,600 baud, 19,200, 38,400. Now this is over a serial connection. What does a serial connection mean? So we're definitely transferring stuff over this wire, right? We have Arduino, we have a USB port, we have a wire in between the two. We're transferring stuff over there. I'm transferring it via a serial interface rather than a parallel interface. What does it mean to transfer stuff serially? Yeah, one after another. So we're doing one bit at a time. So one way you can read baud is bits per second. Okay, think of this almost like internet speed. Okay, so 9,600 baud is 9,600 bits per second. That's how fast we're sending stuff across that connection, all the way up to 250,000 baud. Now, why wouldn't we automatically just choose the fastest? The faster we send things, the better the chances of something getting lost on one of the ends, right? All right, so how many of you have ever done anything with a dial-up modem? The early days of the internet, you know, you dial in and, you know, the modem would that was like a perfect, yeah. So what's happening when we're dialing in with a dial-up modem? Okay, what's it called? What's all that beeping and stuff called? Do you know what we call that? It's called handshaking. Handshaking. And what are we doing during that handshaking process? What's happening with all the beeping? Or do they just make it sound techie? Like, well, you got to have beeps and stuff. That means smart stuff's happening. Sort of, but we're actually looking at before that. All that handshaking is trying to figure out, because you're talking to another modem. You have two modems talking to each other, right? And what are you trying to figure out? You're figuring out what is the fastest speed that we can talk to each other without screwing up, right? Why can't they screw up? Why can't the communication screw up between those two?
Because TCP doesn't allow.
Well, TCP wasn't out yet.
Oh, I say you are going to establish that, so you cannot.
Yeah, TCP/IP protects packet loss, right? So TCP/IP says if we send data over this channel, we're going to send it on this side, we're going to package it up, we're going to send it, we guarantee it gets reassembled on the other side, but we're going to check. We're going to make sure it got sent and arrived, and we got all the parts so we can reassemble it. TCP protects against that, right? And that's what we run over the internet when we have a packet switch network or something like that. We're running TCP/IP as the protection piece for it. You can't hear. I can't hear you. Can you hear me? Nod if you can hear me. I haven't changed anything on my side. Let's see, you're not moving good. Well, I don't know.
I bet he. Yeah, yesterday we have the same issue.
Oh, hold on. I do have a theory. Let me try something here. What about now? Can you hear me now? See, we got a reaction. I'm going to mute myself.
Yeah. Oh gosh.
Mute and unmute.
We just ignore him.
Can you hear me now? All right. Well, I'm recording it regardless. It's got to be on your end. I didn't change anything on my end.
I thought he was supposed to know it's on his end. We can't hear you. I forget, is there a chat in Zoom?
But we have a communicator. Trying use the translator.
Well, here. Let's do this.
Well, you should be able to see your screen too, so you should be able to see typing.
Just have him call my phone. We'll put him on speaker. Huh? That's actually not a bad idea. Although he did. I think he rebooted.
Yeah, because it was just
Something weird happened. Just 818-322-688. Can you hear me? Hello? You can't hear me. Your speakers are up and everything?
Those should pay us for debugging.
Select test speaker and microphone. Hello? Hello? It's working fine.
Oh yeah, it's working. There's the feedback.
Oh,
Okay.
can you hear me now?
Gonna mute.
So you could hear me through your speakers? Well, but you didn't hear me at the beginning, right? Oh. Oh.
My mistake.
Maybe when he dropped out or something.
Kicking out and asking to rejoin.
Kick him out. Remove him.
Oh, he won't be able to rejoin the meeting.
I guess you can quit and rejoin.
All right. Well, we're going to keep trucking while he's trying to figure that out. Okay. So I was talking about the speed. TCP/IP manages communication channels specifically over Ethernet IP networks to ensure that data arrives reliably on the other end. When we have a serial communication channel that isn't being governed by TCP/IP, like a standard USB, I'm going to plug this into another device, and we're just using a USB serial driver where data is flowing over this cable and nothing's governing it. Nothing, the TCP/IP or something similar is not in charge of it. We have to pick a data rate that is going to be compatible with not having errors. You know, higher the data rate, the more data we can send between the two things in less time, but the more prone it might be to errors. So we might need to change the rate depending on the application we're working with. But you know, so let's see, the serial model limiting settings, but enough to handle most of your serial communication needs. Baud rate, click on the baud rate drop down, select correct baud rate, 9600, blah, blah, blah. All right. So my guess is from this baud rate on this screen, if I click on this guy, that the higher I set this baud rate, the more lag is going to end up in here because it's going to be sampling that thing more often. So they have us setting it at the minimum baud rate of 9600, which should be plenty for what we're trying to accomplish here. All right, so now we're on our blink lesson 2, right? We want something to blink, but that So what do we need? Oh, we only need the R3 because it already has the blinky thing on it. Good. All right, so we're going to learn how to program our blinky thing on our Arduino. So this is going to be our proof of concept that our IDE is talking to the actual Arduino. All right, so you can read through the stuff. Here's the little circle. That's the thing that we're hoping will blink. This guy right here. Okay. So we scroll down, we'll find where the code is. So, oh, it even has a built-in thing for it. So if we go under examples, file examples, go to basics, and click blink. It's going to load up
Yes,
a sketch.
I can hear you now.
All right.
Yeah, I rejoined. I just ended that. Yeah.
So you
Sorry
have to
for.
click the button to join the audio?
Yeah, just I ended the meeting and then again click the link from the Slack which you have given.
All right. Well, it's been going around with people not clicking the audio join audio link.
So yeah, audio. I checked my audios here. It was okay. So
All right.
anyway,
So
I'm
now,
sorry.
now you can click on serial monitor, and does this pop up? Josh?
Yeah.
So under tools, where's my
Under tools.
port? Under tools, port, make sure you select the port for your Arduino Uno.
Okay.
And you do have it plugged into your computer, correct?
Yes, I have plugged the yours.
All right, I'm gonna keep going. All right, so we're gonna go under File,
Okay.
Examples, Basics, and choose something called Blink. And that's gonna load up a sketch. So File, Examples, Basics, Blink. All right, so this is an already working, presumably, sketch. Now again, notice we have our setup. This happens exactly one time, right? When we first launch, this happens one time. Then we have our loop. This happens forever. All right, so we're choosing our digital pin L. This is the built-in LED. This is our output. So we're setting our pin mode. This is a function called pin mode. Our output is going to be the built-in LED. All right, so that's our initial setup. All right, we want our output to go to this thing that's already built on here instead of maybe one of the output pins or multiple output pins, right? We're not outputting to some other random device or something. We're choosing our built-in LED. So that's what we're doing right here, one time. Then we have our loop. What does our loop say? Well, we're going to digitally write to the built-in. Now remember, digital is on or off, right? Okay, so we're going to digitally write where? We're going to write to the built-in LED. What are we going to write? We're going to write high voltage, on. Okay, so this is, we're sending electricity to that guy. This is an on signal. So we're going to send high voltage to the LED. This will turn the LED on. Then we're going to wait for 1 second, 1,000 milliseconds. Then we're going to turn it off. Low voltage, 0. Wait again, loop, blah, 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 blah. Make sense? All right, so that is code to make that guy blink. Now, if you come up here, you can click on this little checkbox that says verify. So this will check your syntax and make sure this guy is, you know, follows all the rules. I think I can. Yeah, it says done compiling, but this will show you if you have any errors. So if like I forget a semicolon here or something like that, that's effectively my compiler. So my compile button is this little checkbox. It says, I'm expecting a semicolon, yada, yada, yada. So that, so make sure that you get no errors. And notice here it says, so Sketch uses 2% of the program storage space. So since we've communicated with our Arduino and presumably we've already selected the right board, we'll see if that's the case right now, it's telling us that we can fit 32 32 kilobytes on this chip. So whatever program we write has to be smaller than 32 kilobytes, assuming this is the correct thing. And if I remember correctly, when we looked at the different boards, that was the amount of memory that was in this board, was 32K. What does that mean for us, that we have a limitation of 32K? How does that impact us as embedded programmers? Well, yeah, we now have to be careful, right? Usually when we're writing software, we have a computer with 4 gigabytes, 8 gigabytes, 16 gigabytes, 32 gigabytes, whatever, a bunch of RAM, and a lot of storage. We don't have that now. We have a very small amount of storage and RAM, relatively speaking. So anything that we launch, anything that we write here has to fit in that small footprint. And the more complex of a problem we're going to solve, the more efficient we have to write our code. We can't just create variables out of the blue just because we want to have extra variables. Eventually, we're going to start running into problems with that. That makes some sense? Okay, so embedded systems by nature are not full-fledged general purpose computers, and therefore have a lot less resources to work with, but they're also a lot less expensive, right? Really, if you think about the parts that are on this Arduino, the Arduino is quite expensive when you buy one. When you think about the actual parts that are here, what the specs are. You can go to Best Buy and buy a budget pleaser laptop for 150 bucks. And you buy this Arduino kit. I think this guy's like, I don't know, 35 bucks or something like that. And I think if you just buy the Arduino, it's like, I don't know, 11 or 12 bucks, 15 bucks, something like that for this one. You can buy smaller, less capable Arduinos for less. But to get all the stuff, get in the kit and use a nice box and stuff, it's like 30 bucks, let's say. That's really pretty expensive given how much the stuff in that box costs, right? This is really, really, really low resource stuff. All right, so we're going to write out a high voltage, delay a second, write out a low voltage, delay a second, compile it, make sure everything seems legit. Now we have this arrow here that says upload. So we've tested it locally and decided, okay, I think my code works. At the very least, it's syntactically accurate. Then we're going to hit this arrow, it says upload, and it's going to upload it over the serial connection to my Arduino. And now you should be able to stare at your Arduino, and it should flash every 1 second. Everybody have it working? All right, so that means that your Arduino is accurately talking to your laptop. And do we lose Josh again?
Yeah, I'm hearing, but yeah. Can you hear me? Yeah.
I can hear you. Yeah, we can hear you. We can't see you. Can you see my screen at least?
Yes, I can see your screen.
Okay. All right, so we have our flashing thing, and as long as we leave this thing connected, it's going to flash forever. Now, what will happen if I disconnect my Arduino from my computer?
It will off.
It is on RAM. Yep. So I'm going to go ahead and just unplug this guy. All right, so I unplugged it. Now, somewhere in there, we should have a 9-volt battery pluggy thingy for this. Somebody have that out already or can conveniently find it? Yeah, and there should be a thing that attaches to the... All right, because the idea here is now I've created this amazing piece of software. It should be this. It plugs into the top of this. And it has a little cable coming off of it. Anybody have their battery already unwrapped? Yeah. All right, I need one of those because I can't unwrap the battery. Well, he doesn't have the attachment yet. Do you have the attachment yet?
If I can.
Killing me. Oh, here. All right, so I have a 9-volt battery here. And this little connection, I'm going to use this to power my Arduino.
Okay.
I'm going to plug this in. Ninja.
Here.
And there is my blinky thing in perpetuity. So I've written a program that I've loaded onto the firmware of this programmable circuit board. And now it can just run off of a very low powered 9-volt battery here. And it is running my loop forever and ever and ever. So now we obviously don't want to undo this. So this is just going to be what this Arduino does for the rest of its life. But realistically, you would want to do something more complex than this. But understand that once you have this working, these batteries can last for a while. You would probably create some sort of case that has this battery in it where this guy doesn't need to be plugged into the wall to solve the problem it's solving. Now, the more things you're having to power off this, faster you're either going to drain this battery, or the more, whatever you're taking away from, you might need a stronger power source in the battery itself. Although I think the maximum power source is only 5 volts. So as long as so a 9-volt battery is good enough for anything this thing's capable of doing. All right, here's your.
Can you show me one more time?
What am I showing you? Can you see my screen? See what I'm holding
Battery.
up?
Yeah, that's right. Okay. Okay.
So I had already loaded it onto the Arduino via USB, and now I'm just powering it off of the battery, and it's just doing what I had loaded onto it.
Okay.
So now this is a piece of hardware that I have programmed that I'm now powering off of something else, and it's just going to keep doing what I told it to do. Make sense? All right. So here, this was Maddie's battery.
I think if the box doesn't have it, maybe somewhere in the makerspace.
Oh, well, you did come with a battery? It's
It
this.
has a
This is the
battery.
part. This is the part you're looking for.
I cannot find it. Oh, here. So it's inside.
Well, I don't need it anymore. Maddie helped me. Was this Maddie's or was this? Well, I don't need it anymore. I got. Maddie's on Amazon ordering Christmas lights.
You have 12 months.
All right. So that was our first little project. So I kind of fast forwarded here, but do they have us change anything so we can? Oh, okay. So they go through, and instead of 1 second, here, I'm going to plug my Arduino back in here. I really feel like it's dangerous for me to use these Arduinos because I haven't necessarily been known to have like the lightest touch. Like I break tables and stuff, just so I feel like I'm going to snap this thing in half. I might need you to do most of the manipulation stuff with this blade because I might break the ports off, especially when we start put pins in. All right, so in the tutorial, they have us change the blink time. I'm actually going to make mine 1/4 of a second, so it'll blink faster. I'll go ahead and compile it, make sure everything's still legit. Then I'll upload it. When you're uploading, you should see 2 lights next to the thing flash. That's the receive and send signals, LEDs. And now you should have a thing that's blinking faster. Blinking faster. All right, so there's some starter sample code thingy. Sure. Huh? Yeah, I don't care. You don't have to show me a picture of that one. Just give me something to grade. Mm-hmm.
Right there. So where it says like the
int LED equals 13, like it's saying that's in there, but I didn't see that in there. So does that just be relevant?
Probably because I think the LED equal 13 is equivalent to this guy right here. I bet you if I choose 13 here, that will still work.
Dr. Littman?
Yeah.
Do you mind if I show my cable that I could not? Is this the cable with this batteries goes? This is the same one? Can you see here?
Yeah, it looks like the same one, but you don't need. You won't need that.
Okay.
I just did it to prove that you can upload something to the Arduino, and then once you're done uploading your code to it, if you don't want to power it off of USB anymore, you could power it off that battery.
Okay.
Yeah. So, I mean, I just ran this, and 13 is the value for it. It's still running just fine. So by using LED built in, usually when something is in all caps like this, it's like a macro constant. So this is a hard-coded value that's built into it. So this allows you to say, I want to use the built-in LED, whatever pin that is, use the built-in LED. That way I don't have to memorize 13. But that's where the 13 thing comes from. Up here, right here, Alexis.
It's just a resource number.
Yeah. Right. Yeah. So his point here is that if you use this, the Arduino constant for LED built in, and you upload your same script, your same sketch is what they're called, Arduinos, to a different hardware-based board, it'll still work because that hardware will call its appropriate pin for its built-in LED. Where if I hard code a 13 in here, it's always going to output to pin 13, which on this board is accurate, but on a different hardware board might not be the pin out for the built-in LED. Okay, so you want to like have nothing on it? Well, you probably get the reset button, but I don't know that you can. Yeah, I don't know that you can. Maybe you could press and hold that. There's probably a way to factory reset it. I mean, otherwise you just take the code out of here and yeah. I mean, here's a fresh one right here. There we go. Now you got to reset board. This is a guy that does nothing. All right. All right, so that was lesson 2, right? So does that cover all of the Arduino stuff for next week? Oh, so do we want to do 3 or do you want to leave 3 for you? Okay, so we're going to do 3. We're in class anyways. This is our lab stuff, so this is less you'll have to do outside of class. Let's call that. Go. What's up? What? Like how we do number 3?
How do you use the audio library, I guess?
Oh, well, we're not. Yeah, we have ability to use it now, but you're gonna have to use third-party things, plugs and stuff to do it. Yeah, it's not part of the thing itself. We just now support it. All right, so we need some components here. So I need my R3, and I need a 5mm red LED blade, like a surgeon. All right, I need an LED. I need a 220 ohm resistor. And here we can go up to our pictures here.
Probably I should
Here.
keep it up there or put it up together.
That's right. So I'm going to open this a second time so I can have my pictures of things up here.
So, where is?
All right, I'm gonna show you a picture. Where's my ohm? What did I say I needed?
We don't have this tab. I don't think do you have any other tab filters?
Yeah, I was looking for what the.
I think the color is different. They're all different ones.
Oh, there's a bunch in there.
There is yeah, I see. We are looking for
220.
220. Okay.
And then a 1K ohm resistor.
Okay, let me get into 220 first. Okay.
I'll make a recommendation here. You're probably going to be fine regardless, but I would recommend that while you're plugging things into this, you unplug it from USB. You probably would not die, but if we're just being official here, you generally don't plug metal contacts into something with there's an exposed metal contact on the other end without properly grounding yourself first. Mm-hmm. All right, so all right, and then I need a 10K ohm resistor.
Yeah. 1K, 10K,
and a 220. And then I need 2 male-to-male jumper wires.
Just let me check it again to see I've got okay, is it correct? Now I need a jumper. We only have one type of jumper.
The male-to-male, the ones that have the pins on both sides.
Yeah.
Not those.
Yeah. This one is.
Yeah, those are male-to-male.
This is the one. And we need another one. Okay, I got another one. I just try to be the same, the color that they want.
Yeah. Oh, I see. All right. So has everybody collected their parts? Oh, I haven't gotten to that part yet. We're going to do a breadboard. As long as it's in the right row, it should be fine.
So red will connect to 5.
All right, so collect all your parts, and then we're going to grab our breadboard.
Oh, it has a number.
Oh, the 200.
Yeah.
Okay, that's
Yeah.
The number. Technically, you can read it by the lines, but I cannot. I don't remember it.
All right, so just real quick, I know everybody's paying attention, but let me just tell you about breadboards real quick. This piece thing we have here, this again falls into the category of rapid prototyping. This is what's called a solderless breadboard. That's why you're using the male-to-male cables to plug stuff in easily. So this allows you to quickly create prototypes, because usually if you go to a historical breadboard, you would have a piece of circuitry with holes in it, and you'd actually have to take the metal and some solder and melt it on there to attach the metal relatively permanently to the board. Where a breadboard like this allows you to just plug it in, test it. If things aren't quite right, you can unplug it and things like that. All right, so the breadboard allows you to accomplish those types of things, and anything you put in the same row is part of that communication channel. So that means on this particular breadboard, we can have, what, 5 things? 5 things on a single shared circuit. You probably can do some bridging stuff too and pull off more than 5, but let's call it 5 safely. I don't know. I'm guessing this isn't a highly rated breadboard, so you might not want to be pumping full USB-C output into it.
Okay, right now this is using a 200. So now it's like
All right.
So it's using resistor to control the brightness.
Mm-hmm.
The higher it is, the lower the light should be.
Oh, the resistor?
Yeah, this one. So if we changing that, it will be
Brighter or,
oh yeah,
so that's my 220?
that is 230.
All right, so yeah, so with the 220, so what are my inputs here? So I have what pin? Here, let me just scroll down. I'll just see what it, I'll be able to see it better on here. Anyways.
So actually, this is connecting 5 voltage and the ground.
Yep.
Red is 5 voltage, that is ground, and it's going a circuit and with resistance.
Mm-hmm.
Very basic circuit.
Oh, here's my picture. Yeah, so here's the picture of what we're accomplishing here. So depending on, so this is my ground coming into this outer rail. So, so you have your ground pin going in here. Then you have your 5 volt coming in here. So we're powering something. So everything flows to ground. So this is going to power the board. We have our LED, which is, Blade has this set up a little differently in this, but it's fine, it's the same thing. Yeah, so we're getting our LED power is coming through this post, and it's ground here. So electricity flows up here into the LED, lighting it, and then down to ground. And then this is the ground on the actual, to complete the circuit. Okay, circuit, you have to.
And so is the light supposed to plug it in, and is the light supposed to go off?
No, light's just on. So light should just be on when you plug it in. And the thing is right now I'm using a 220 ohm resistor. So what's happening here? So kind of follow, everybody pay attention for a second. Let me show you what's going on. So the power is coming here. So this power is flowing all along this rail. Okay. Now that power is going from this pin right here, this port, through this resistor. So it's resisting the electricity, turning it down some. All right. Going here, and this is where my LED is picking up its electricity, is on the other side of this resistor. So it's getting less than the full blast because we're resisting it by, we're kind of pushing back against it by 220 ohms. All right, so that electricity is then going up to here, giving us a less bright light. Make sense? No, you could put these, you could have it set up right here if you wanted to. This has electricity coming to it. I think the electricity goes from here up. I don't think it covers the whole thing. It depends how it's wired underneath. Actually, I bet the way it's wired, it probably does cover the whole thing.
It is, yeah. If you look at back, it is a cable from the one to another.
Yeah, so by plugging 5 volts in here, this entire, what would we call that, row? By the way it's organized here, this is a row, so this whole row is a power source. This whole row is a ground source. So anything plugged into this top row is ground, anything plugged into this next row gets power. All right, so we have this resistor here bridged from this power port over here. So now, in terms of how breadboards work, okay, so everybody pay attention again. Just to give you an idea how breadboards actually function. So I've told you that everything along this row is power, everything along this row is ground. Now, I have this resistor here going from this port, which is power, into this row. anything that's in any of these 5 pins here is part of this bridge. Does that make sense? So the fact that I have this LED plugged in here as opposed to here as opposed to here does not matter. Okay?
It's
So
like
that
connector.
allows me to share
It's
anything
connecting.
from here across these 5. So I can have multiple things there. So that's you know, that's what a breadboard does. It allows you to kind of have multiple things all plugged in. All right. So once you've done this the first time, try plugging in your 1K resistor. So we're going to resist the electricity even stronger. So your light should be weaker, right? So if we change the 220 to a 1K, we should see a even duller light. Yeah, whatever. Well, either one of them, if it's a 1K or a 10K, it's going to be less bright. So the idea here is that 220 should be relatively bright. If you take the resistor completely out and just run it, it should be as bright as it can be. That's going to give you full unresisted LED. Don't do that.
The only thing is, it might burn. It might burn.
But the LEDs aren't rated to 5 volts? Oh. All right, resist your LEDs. Don't. don't have it.
I don't know which is, but this is a different one.
Okay. Don't do that. Yeah, what we were just told is if you don't put a resistor there, the 5-volt power flowing directly into your LED is too much. It will burn out your LED. Yeah. At 5 volts. Yeah. So the higher the resistance, the less energy is going to get through, the duller the light will be. Yeah. The LED has a power in and a ground. All right, so everybody try a couple of different resistors. Oh, we haven't got anything going yet? I know. Hopefully the recording didn't fail.
It's recording.
Blade started messing with stuff.
Really? Is that it's like having a shotgun?
You knocked this pretty hard.
Oh, okay. That's fine. It's just it's not because I burned something.
Yeah, it says it's still recording.
Okay. Probably typing something there.
I think I just have to go back to my screen share. Oh, good. Here. So if you want to come up and I don't want to move it because this thing's kind of messed up, but if you want to check out the range, Blade has mine set up with all 3 resistors on it with 3 different LEDs. So you can see the different brightnesses. It's up here. I don't want to move it because it just knocked off my L. If you want to come browse, feel free to come browse.
You just change for the different ones, right? When you spin it off.
But the thing is, so as long as the positive side is coming from the positive,
10K. Okay.
one side is positive.
We should have,
One side needs to be connected.
what's that one? We should have like needle head will be better.
Oh, the needle nose pliers.
Yeah.
Yeah, we could bring some tools down next time, I think.
Yeah, we find one tweezer will be better.
Well, I need the needle nose pliers, so I have to fix my shoe.
If you want, we have, I think we have in the.
My laces got messed up on my shoe. Well, my old man laces, the laces that aren't laces, they're just stretchy things. The light is blinking on and off.
Yes.
Well, the program wouldn't do that because the program is only going to internal pin 13 for the LED for the blinking.
Yeah, I was like, oh, I'll just plug it into the breadboard, make it really bright, and it's all black on top,
Yeah.
or just like poof.
That's a basic knowledge. Never direct.
Dr. Littman,
Yes.
I am not sure if you can see mine. Can you see if I just
Normally,
Well, I can see. Yeah, hold on. Let me make that bigger. Okay. Is it lit up?
yeah.
Okay.
Lit up.
Yep. And did you try some of the different resistors?
As for the picture I've tried this one. I'm going to try which you have shown the.
Yes. Yeah, that's good enough.
Do you want all three pictures?
I don't really care. For this first one, it's pretty obvious. You're gonna have different projects for the future ones.
Don't forget Bible homework. Hi, Ani. Hey, guys.
The same here is in the same table.
Yeah.
Or this one is.
All right. I have repaired my shoe.
Just the use of knowledge of the writing.
Yeah, you messaged me,
I
right?
guess like to go it. So if I don't show up and I watch the recording, is that all right? I'm gonna try to come.
Well, next week is this day, right?
Yes.
Yeah. So in class we'll be messing with the thing. So like I said to everybody, if this is something you'd prefer to do at home and not as a group in class, feel free. Otherwise, come to class. We'll do this in class as a lab. It'll be less homework you have to do at home, but also you have everybody else to help figure out what's going on with it, But so yeah, you'll just have to do it on your own. Yes. The who? What? It shouldn't be blinking on and off. Are you sure you have your resistor? Well, I don't even know in what world it should be blinking on and off. Do you have your LED plugged in well? Okay. Where is it in the circuit? So it's here? But you still have it grounded? Why would it be blinking?
Yeah. So the 10K light is gonna be lower than the.
I don't know why it's blinking.
So think about that.
Oh,
You
no,
have-
Maddie, don't forget.
You have 5 voltage coming out.
Yeah.
So
Wait, so you saying
any
the
resistance
higher
will take
old one we did, it would be dimmer?
Yeah.
Okay.
Yeah, because you're resisting more. You're resisting against the electricity.
Then if you put so that's it. This is yeah, that's the logic.
You can reuse the resistor. Absolutely. Until they break. Yep.
I just uploaded to Slack a picture showing the 3 different levels of brightness for the ohms if you wanted to look at.
And you want a picture of those two, right?
Yeah, just one picture is fine. Because this is all the same. Yeah, no, it's good. So is this fun? Okay, well, good. Cool.
You mean employee? Not employer.
That's a good thing, right? Oh.
That's great.
What?
Can you ask? Are you still recording?
Yeah. We're gonna stop recording. I could pause recording. You want me to pause recording?
For like 2 seconds.
All right, hold on.
Oh, I love it.
Blocking it.
That's right.